When ancient man looked to the heavens for guidance from the gods, he noticed star patterns and began to document their movement across the heavens. The ancients believed that the earth was flat, but around 350 BC, Aristotle proved that the earth was round. Later, about 150 AD, Ptolemy presented the geocentric theory, the belief that the earth is stationary at the center of the universe, with the sun, moon, stars, and planets revolving around it in complex orbits. In the 1500s, Nicholas Copernicus of Poland presented the heliocentric theory, the belief that the Earth revolves around the sun as it rotates on its axis. This aspect of astronomy evolved into an intricate study of planetary motion known as orbital mechanics. Today, orbital mechanics is applied to space flight and satellites that orbit the Earth or travel beyond our solar system. In the early 1600s, Johann Kepler, a German mathematician, using the data on planetary observations collected by the Danish scientist Tycho Brahe, developed 3 laws of planetary motion. Kepler's first law states,
all planets move in elliptical orbits with the sun at one focus and the other focus empty.
Applied to Earth satellites, the center of the Earth becomes one focus, with the other focus empty. For circular orbits, the 2 foci coincide. Kepler's second law, the law of areas,
this is
states,
space. I'm in space.
The line joining the planet to the sun sweeps over equal areas in equal time intervals.
When a satellite orbits, the line joining it to the Earth sweeps over equal areas in equal periods of time. If areas 1, 2, and 3 are equal, times 1, 2, and 3 are also equal. Therefore, the speed of the satellite changes depending on its distance from the center of the Earth. Speed is greatest at the point in the orbit closest to the Earth, called perigee, and is slowest at the point farthest from the Earth, called apogee. It is important to note that the orbit followed by a satellite is not dependent on its mass. A large, heavy satellite could be in the same orbit with a small, light one, each sweeping out equal areas in equal periods of time. Kepler's third law, the law of periods, relates the time required for a planet to make one complete trip around the sun calculated. The shape of an orbit is defined by the second orbital element called eccentricity. For all ellipses, the value of eccentricity lies between 0 and 1. The larger the value, the more elliptical the orbit. A spacecraft in Earth orbit with an eccentricity equal to or greater than 1 will escape the Earth's gravitational field. When orienting an orbit in space, a three-dimensional coordinate system must be defined. The coordinate system commonly used is the geocentric equatorial coordinate system, which has its origin at the Earth's center. This coordinate system is a non-rotating reference system in which a satellite's orbital plane tends to remain fixed relative to the stars while the Earth turns beneath it. The XY plane is the Earth's equatorial plane. The positive x-axis points to the vernal equinox. This is the point where the sun appears to cross the Earth's equator on its way north on the first day of spring each year. The z-axis is along the Earth's spin axis toward the North Pole. Nodes are points in a satellite's orbit which intersect the Earth's equatorial plane. The ascending node is the point at which the spacecraft crosses the equator going from south to north. The descending node is where the spacecraft crosses the equator going from north to south. The line joining the two nodes is called the line of nodes. The orientation of an orbit is determined by three orbital element angles. The right ascension of the ascending node is the angle between the x-axis and the ascending node. It is always measured eastward from the direction away from the vernal equinox in the Earth's equatorial plane. The argument of perigee is the angle between the ascending node and the point of perigee. It is measured in the orbital plane in the direction of spacecraft motion. Inclination is the angle between the equatorial plane and the orbital plane. A satellite which has an eastward velocity component at the ascending node has an orbital inclination lying between 0 and 90 degrees. Such an orbit is called a prograde orbit. A satellite which moves due north at the ascending node is in a polar orbit. Polar orbits have an orbital inclination of exactly 90 degrees. A satellite with a westward velocity component at the ascending node is in a retrograde orbit and has an orbital inclination between 90 and 180 degrees. The five orbital elements explained thus far describe the size, shape, and orientation of the orbit in space. The final element is a time value used to locate the satellite in its orbit. A satellite moves in a very predictable manner. It stays on schedule. Thus, if the time at which a satellite passes a particular point is known, the time when it will pass any other point can be determined. The particular point chosen is perigee, and the time of perigee passage is the last of the six orbital elements. The six orbital elements depict a spacecraft's orbit in non-rotating coordinates. To visualize an orbit relative to the rotating Earth, a projection traces the spacecraft's position on the Earth's surface. The projected path is called the ground track. As a satellite orbits the Earth, the ground track shifts westward. There are two causes for this. First, the primary contributor is the Earth's rotation toward the east under the orbital plane. Second, because the Earth is not a uniform sphere and bulges at the equator, its gravity is greatest at the equator. This causes the orbital plane to rotate slowly around the Earth's polar axis in a motion called precession. Precession is toward the west, for prograde orbits and toward the east for retrograde orbits. For low Earth orbits, such as those of the Space Shuttle at 150 miles altitude, the westward shift of the ground track due to the Earth's rotation is about 22.5 degrees, while the shift due to precession is only about a half degree. The inclination of a satellite orbit determines the north and south latitude limits of its ground track. The minimum orbital inclination is equal to the latitude of the launch site and is achieved by launching due east. For example, if a satellite is launched due east out of the Kennedy Space Center, which is located at 28.5 degrees north latitude, some of the factors affecting the launch window are launch and orbit lighting conditions, sun angles, payload orbit requirements, rendezvous phasing if a rendezvous is planned, tracking and communication requirements, and collision avoidance with other orbiting objects, to name a few. One of the factors defining the launch window for the Space Shuttle is launch lighting conditions, which can be illustrated by plotting time versus day of year. On this plot, we see daylight and darkness at the launch site. The longer daylight hours occur in the middle of the year, summertime. If daylight conditions are required for a convenient emergency landing site for the space shuttle, the launch window would now look like this. During the winter months, the available launch window for lighting conditions alone can be as little as 3 hours per day. When combined with the many other launch factors, the launch window becomes even more constrained. The choice of a particular launch vehicle for a mission depends upon the weight and size of the payload and the desired orbit. Expendable rockets used to place spacecraft in orbit usually consist of several stages that may incorporate both solid and liquid propellants for propulsion. When the fuel in each stage is depleted, the spent stage is jettisoned. Staging offers the advantage of discarding weight when it is no longer needed. The space shuttle is a two-stage system. At liftoff, the 2 solid rocket boosters and 3 space shuttle main engines are all producing thrust. After approximately 2 minutes of flight, at an altitude of 25 miles, the fuel in the solid rocket boosters is depleted and they are jettisoned. The 3 main engines, fueled by liquid oxygen and liquid hydrogen carried in the external tank, continue to burn for several minutes until the shuttle reaches its cutoff velocity. At this time, the main engines are shut down and the external tank is jettisoned. 2 additional burns using the orbiter's maneuvering system referred to as ohms are required to place the orbiter in its final orbit. The ohms 1 burn occurs about 2 minutes after main engine shutdown and establishes the orbital apogee point. The ohms 2 burn takes place approximately 30 minutes later and circular There are situations which require an orbital plane change, such as setting up a rendezvous or placing a satellite in an equatorial orbit. To change the inclination, the thrust vector must be directed at an angle to the orbital plane. A thrust with a component that is perpendicular to the orbital plane at either the ascending or descending node will rotate the orbital plane about the line of nodes. A northerly out-of-plane thrust at the ascending node will increase the inclination of a prograde orbit, while a southerly thrust will decrease it. Out-of-plane thrusts require considerable amounts of fuel and are performed only when absolutely required. The Space Shuttle, for example, using all of its onboard propellant, is capable of an on-orbit plane change of less than 3 degrees. Satellite orbital planes and altitudes are determined by their design mission, which very often includes a field of view requirement for optical or communications purposes. The field of view of a satellite is defined as the area of the Earth's surface that is in view from the satellite at any given time. Satellites in high orbits have greater fields of view than those in lower orbits. For example, a satellite at an altitude of 800 nautical miles has a circular field of view with a diameter of about 4,100 nautical miles. A satellite at 200 nautical miles has a circular field of view with a diameter of about 2,000 nautical miles. Low-orbit satellites are often used for photography and other types of Earth observation. A satellite placed in a low-inclination circular orbit at an altitude of about 19,300 nautical miles will have an angular velocity exactly equal to that of the Earth's. The satellite would seem to remain stationary in longitude as viewed from the ground. Such orbits are called geosynchronous and are used to provide a continuous communications capability among any system of ground stations within their field of view. The geosynchronous orbit field of view is constant and is limited to a latitude zone of about 70 degrees north and south of the equator. Effective satellite communications from geosynchronous orbit is not possible at either pole. However, because of their altitude, their field of view covers nearly half the globe. A special There are other, much smaller forces which will cause a spacecraft to deviate from its desired orbit. These forces cause what are known as orbital perturbations. Orbital precession, which is used to obtain sun-synchronous orbits, results from the perturbing effects of the Earth's non-spherical shape. Other perturbing forces are the gravitational pull of the Sun, the Moon, and planets, and solar winds, which are charged streams of protons and electrons that heat the Earth's atmosphere and increase atmospheric drag. In most cases, perturbing forces can be compensated for in the spacecraft and orbit design and present no major problems. If the forces disturb the orbit too much, thrusters can be fired to re-establish its desired orbital orientation or altitude. This is particularly true for spacecraft orbiting at very low altitudes, where the effects of atmospheric drag are greater and, if not compensated for, will eventually cause the spacecraft to deorbit. A spacecraft's operational lifetime is frequently limited only by the amount of fuel available to maintain its desired orbit. When its useful life is complete, a satellite is left in orbit or is deorbited, burning up when re-entering the Earth's atmosphere. When the space shuttle completes its orbital mission, it executes a precise retrograde burn to initiate its controlled return to Earth. This burn occurs nearly halfway around the Earth from the landing site. The new orbit established by the retrograde burn causes the orbiter to enter the Earth's atmosphere about 4,000 miles from the landing site. During the period the orbiter descends from its orbital altitude to atmospheric re-entry, its attitude is maintained by the use of reaction control jets located in the nose and tail of the orbiter. Once the orbiter enters the Earth's atmosphere, its wing and tail aerosurfaces begin to become effective and gradually replace the jets for attitude control. As the orbiter nears the landing field, it maneuvers to a long, straight-in approach at an angle of 17 to 19 degrees. Nearing the runway, it executes a flare maneuver to reduce its sink rate and glides to a touchdown at approximately 230 miles per hour. As the orbiter rolls to a stop, our journey into the world of orbital mechanics comes to an end for now. This is only the basics of orbital mechanics, an intricate study of planetary and satellite motion. The next time you see a launch, you will see it from a different, somewhat knowledgeable perspective. You will understand the fundamentals of spaceflight.
Pretty good, right? Dude, that video rules. I love that, dude. Oh, man. That's good stuff. That's good stuff. Isn't that cool? Did you learn something? Hopefully you did. Lightning orbits, man. Molna. Da. Хорошо. Very nice. Not Carl Sagan 5 out of 10. Hey, this one's free. All right, let me fire up YouTube, then we'll get started.
Engines roar like ancient beasts. Flames consume but never feast. Metal wings slice the void apart. A funeral pyre, a rocket's heart. Does the air terror, does it yield? What's the cost of the battlefield? Volcasonic retro propulsion. Fire fights fire in the skies. Combustion. The plasma storms and blackout seas. Gravity chains snap with red rivers, burning trails, echoes scream where silence fails. Ashes rain, the sky won't care, but we keep climbing unaware. In another, in another, in another, in another, in another, in another, in another.
Eat another piece of chicken. Those are the lyrics, right? It doesn't matter. Hello. Welcome to the Space and Rocket Review. You two girls, tell your friends. Space and Rocket Review. Elon, blah, blah, Elon, blah, blah. EJ, Star Trek or Star Wars? I like either of them. I grew up watching Star Wars, but my parents watched Star Trek. And I kind of grew up with both of them, but I watched more Star Wars when I was younger. But I find myself watching more Star Trek as I'm older. Does that make sense? Hello, how are you? Fine, thank you. I'm good, Ship. How are you? Let's go. What's up? What's up, Logan? How are you? Need for Speed Live has a nice thing going right now. I didn't know Need for Speed streamed live. You see yourself as Riker? No. I think Gene in the Star. Did you guys watch the Starbase Stakeout stream? The Starbase Stakeout stream. People were like, oh, VJ was a Star Trek character. Which one would be? I got Scotty the most. I got Scotty. So not Riker. Sorry. Not Riker at all. Scotty is what I got. And you know what? I'm good with that. Yeah. I'm good with that. Yeah, no, that's fair. Chekhov? to be Chekhov. Why do I want to be Chekhov? You do a good Scotty impersonation though. Can't change the laws of physics, chat. You definitely be Data. Data? What? You're 100% right, Gary. You got the beard, the height, and the bad back. I don't. No, it's false. It's fiction. We made it up. We made it up. It never happened. It never happened. I'm not a tribble. That. You'd be a Romulan. This conversation sucks. I'm changing the subject. You guys want to hear? You know, it's kind of a funny conversation. You guys want to see a joke? Here. There you go. There's another joke. The European Space Agency, ESA, is paying a company called IDS to make that. Jordy, Miles, Bilana. It's definitely Scotty. Yeah. All right. Yeah, they're making that. No, not that. So this, don't get me wrong, I don't know how. That is for a little while back we covered a story about how ESA is paying Avio to build a reusable upper stage that has forward flaperons and rear flaperons, and then has an SRB first stage. They're paying Avio, you know, to make it, who has no experience with reusable spacecraft. The reusable upper stage is liquid fuel, and they have no experience making liquid fuel vehicles. Avio almost exclusively makes solid rocket fueled vehicles. Okay. And yeah, it's supposed to come down and land. And I guess it's supposed to come down and land on that. I don't know why it has a catch net. Are they planning to catch that stage? Yeah, it's a little bit peculiar, but what is this? What is over there? Ah, yes, a cylinder. Yeah. Please tell me this is fake. Nope. I don't really get what are you trying to do? They're making a reusable stage, but what is this? A drone ship? What is it supposed to land? Like, in one picture, it kind of looks like a drone ship with a landing pad on it, but there's also the net, which just happened to look exactly like they look exactly like Mystery. I mean, one of the Aryan sub companies are grafting money out to the ESA to build another failure. Hey, Tessa, that sounds very negative, but yeah. So, I mean, it's kind of cool, but yeah, that the ESA shelled out some cash to a company called IDS to make this craft for Avio's reusable upper stage vehicle. Okay. All right. I can understand, you know, giving the contract to Avio for a reusable upper stage and having them kind of go at it. I can understand that. That's kind of cool. Why? Why are you buying this? What is this for? What is this for? You're buying infrastructure for a launch mechanism that doesn't exist. And what's the hope here? Like, the hope here is to have a upper stage reusable small sat launcher that lands on this. What are we doing with this? What's the ESA? What are you doing? Why would you buy this? Just have it splash down in the water. I don't understand why you would buy this right now. A dedicated naval asset for a piece of flight hardware that's a drawing on a whiteboard at Avio's R&D facility at this point. Why would you? Is this thing multiple use? Is it going to catch fairings from Ariane 6 or something? Is it going to catch fairings from or something? Is it going to catch something from somewhere? Like, what is this thing designed to do? We're talking about building a ship here. We're talking about building a ship here that's going to maybe do some type of at-sea recovery, maybe in the next 10 years, maybe. Why would ESA, who gave this money out on the premise that it's a developmental vehicle, why would they be buying dedicated naval assets for it? A developmental vehicle. I don't get it. That doesn't make any sense. They need some sort of hardware to show. Why not a boat? Maybe they're very secretly cooking. I don't know. I don't know, dude. That's very weird. I don't know why at this phase of design you would even bother with a recovery vessel. What if it doesn't work? What if it doesn't work? Are they going to pay Avio to do an iterative design here and keep redesigning it till they eventually catch one? And then what? Then what? Then routine operations from a small sat, a reusable small sat launcher? What are we doing here? Just to speak in Sebastian Vettel terms. I mean, honestly, what are we doing here? What are we doing here? Honestly, what is this, racing or ping pong? Like, I don't really get what's the point. Why would you buy a ship right now? That's like, okay, I do live streaming. You know that. I'm a live stream commentator. I play games, etc., etc. I'm a live streamer. Everybody knows this. If you don't, I honestly don't know what to tell you. I've talked to a lot of people. You know, a lot of people ask, like, oh, how do I do that? How do I get into live streaming? How do I get into live streaming? And my answer is always just do it. Just start doing it. And they're like, oh, well, no, I can't start doing it. I don't have a good setup. I don't have a good setup. I don't have a setup like yours. I don't even have a nice camera. Dude, I started streaming with a crappy webcam. Actually, I started streaming with no webcam. My original streams from like 15 years ago was just my commentary over the video game screen. There was no alerter. There was no tip thing. It was just me, the game, and chat, and that's it. And that's, well, I kind of try to still do that nowadays. Did you buy a boat? No. But no, I didn't. But the point that I'm trying to say is that, you know, this is like somebody wanting to get into live streaming now and then just dropping like $5,000 on a streaming setup. That's not how you do this. That's not how you do this. You start streaming with a minimum viable product and then work your ways up from there. Buying that ship is like buying a $5,000 streaming setup to live stream when you have no personality. That's fine, but you got to do the whole, you got to grow a personality. You got to do the personality thing. That's really important to live streaming. Very important. I don't understand why you would even bother buying a naval asset at this point for an experimental program that might be reusable maybe sometime in the future. That is just, it's very strange. However, money. But money. However, I will say this just so that the European Space Agency is at least committed to doing some type of development with reuse. At least I would hope they are. Because, yeah, that ship's going to get expensive real quick. I watch you for your looks, not your personality. Yeah, but you could watch me for my personality, though. You don't watch me for personality, but you could. Do I start with a paper airplane and a paper boat? That's how I start my aerospace company. You give it a try? All right, I'll take it. Yeah, ship. Yeah, you go do that. There's a reason SpaceX didn't spend billions on Starship. They needed to start small and then grow. He's just stupid and that's it. Dang, dude. But I'm not married. You are now. To America. Speaking of America, headphone users. Oh no, I had the volume turned down, thank God. But I'm going to turn it up now. Headphone users, you might want to see this. This is, but you've been doing it without a personality for a dozen years so far, and you're doing okay. You stand by your last. Thanks, asshole. Appreciate you. Here, watch this. Yeah? Yeah, that's pretty good. SpaceX released more footage from Flight 11. Here, we'll watch it with the volume down this time. Dude, that is absolutely savage. That is a savage amount of thrust going on here. I'll ask time and time again, where the frick did this thing come from? Imagine that, but 33 beautifully blue Raptor 3s. Yeah. I'm a professional photographer. Everything I know about exposure is tested in this image. Oh, I bet, dude. How do you not get it to blow out? What's the exposure of this camera shot, Fall? It's got to be like nothing. Dude, what's your aperture? The aperture's got to be like a little pinprick, you know what I'm saying? Drugs and tons of hard work. Yeah, right. Does the next version of Raptor have even more thrust planned? I don't know. Dude, look at that freaking thing. How does the camera survive? It looks like it didn't. That is so cool. Oh my goodness. That hose got messed up. Oh yeah, the hose got destroyed right there. It got wrecked. What do those small hoses do? bleed lines, if I'm remembering right. He got hosed pretty bad. In terms of how the camera survives, I have no idea, dude. You know what's kind of nuts to me? Like right here, there's such a vacuum being made in here that, you know, it's very, you can clearly see all the umbilicals, and the hoses don't really get too messed up. They get messed up after the vehicle separates from the pad, and there's no longer vacuum up in here, and then the flames just absolutely grill everything. Like the plume is going in, right? You could see it from the spike right there, and then the spike is eventually going to go up, and what this cone is all the gases from the rocket engines are all collapsing in on each other because of atmospheric pressure, and then they bounce out. They kind of bounce off of each other. Watch what happens when the cone down here envelops the entire pad. Fire! 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 Raptor Chill Collection. Yeah, they're bleed lines. Yep. I'm betting those are considered a consumable. I mean, Tessa, I'll bet you that's one of the things they fixed with the new pad. Fire! Settle down, Beavis. See what I mean? When the rocket gets far enough away, the plume has enough time to expand out over the entire pad, and it just turned off. Well, I was about to say all hell breaks loose, but and that's where the hose really starts to get angry. Dude, that is violent. SpaceX reusable rocket, expendable pad. Why no flame trench today? It's Thursday, John. Flame trench is tomorrow, dude. You scared the crap out of me for a second. I was like, no, I thought it was Thursday. You scared me, dude. I was like, oh no. Oh no, they're probably wondering where I Flame trench is tomorrow. I signed up for it this morning, yes. Could you explain the colors inside of the nozzles? Different materials, Shinar. Yeah, it's just different alloys of metal. The throat is made out of something that you could like actually throw into a volcano and it would be fine, you know? We got different materials. This is a liner in here, I know that. This lighter part on the outer parts of the nozzle, dude, that's a liner for the cooling channels. And then there's I don't know. I know they're different metal alloys. I have no freaking idea what they're for or what they are, what they're made out of. It's probably a proprietary SpaceX thing. What are all those hoses? The hoses. This is for pulling all of the puns out of the vehicle. So I mean, we'd need to attach you to one. Nova. No, they're Raptor bleed. They're the bleed lines. When the Raptors chill down, this pulls the gases away. So these were retrofitted. Do you remember, guys, when Booster 7 was on the pad and they spin started it and it it backfired on the pad? Yeah, they installed those after to make sure that that doesn't happen again. The spin boom, exactly. Too bad NSF didn't get permission to have the flame trench in pad 1 in the Pad 1 shower head. That's why you got a tungsten wedding band. I might not be able to survive a swim in molten iron, but my wedding band will. Mine's titanium. Yeah, mine's titanium. Titanium is cool. Never rusts. And dude, and mana, this thing is, I mean, like yours, this is absurdly strong. Cryo, 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 spin prime, satisfy, spin prime, satisfy, spin prime, cryo test. If you look at booster 7. Good stuff. So, yeah, SpaceX posted this. They also posted something else you guys might want to see. Yours is hard. Yeah, well, mine's taller. Here's the sky. I have not checked out Subway Builder. So what about the ones near the center? Are they hooked up? Are they hooked up to ones on the outside? That also brings up the question, so why so many small hoses? I don't know about, I don't think the center ones are hooked up to anything. I think they just have a straight bleed nuclear. This also brings up the questions, why so many small hoses? Because it was retrofitted. Because SpaceX for the longest time, their kind of milestone was just get the thing off the pad and get the thing into space for data, for testing data to validate their simulations. So it wasn't really necessarily about making it perfect. It's about making it work. So they just attached a bunch of hoses to it. Just like another good example, nuclear, would be the ship static fire test stand that they just mounted on that OLM and then just jerry-rigged a bunch of plumbing to it so they could static fire a starship. That. They just make it work. Make it work first. Figure out optimizations later. That's SpaceX's mantra to a T, and that's actually pretty. That's pretty damn good advice. The center go through the BQD. Yeah, that's right. Mm-hmm. They don't have hoses like that. Yeah. Anyway. Here's a nice shot of the sky that SpaceX posted. Oh, yeah. Hey, Aurora. Vanished. Bro. That landing, despite Ship 38 missing some tiles, looked pretty damn precise to me, dude. So the flamey end was both up and down. Well, it was kind of sideways. Dude. Yeah, Ari, right? That's why they don't show the explosions. They're saying the booster performed so well, this warped nozzles, that they clearly didn't care. What is that flame at the top? I can't figure out what that flame is up there, dudes. I mean, my first thing is like methane header tank, but the header tank is not on the outer skin of the vehicle. The header tank is kind of like inside of it. It's not part of the outer skin of the vehicle. So if the header tank did, in fact, spring a leak, the fire would be kind of in the payload bay, so to speak. Some are saying the autogenous pressurization line. Isn't that on the other side? Isn't that on the back side of the vehicle? It's on the leeward side. Speculation thinks a main methane tank leaked into the payload bay. With how much burn through they got spoiled, I wouldn't be surprised. Wouldn't the warp nozzle only decrease performance, which the programming would be able to compensate for? No. They fired the engines into the bent nozzles, and they kind of sprang back into position. Nuclear. Yeah. Milge, I think this one was spot on, dude. I mean, just look at how buoy cam framed the shot. It is perfect. Oh yeah, the payload bay door would be in the way. That's right, guys. Yeah, that's a good point. Do we know Starship's cross range? And if we do, what is the shuttle's? The shuttle has more cross range than Starship, but Starship has more than previously anticipated. I was talking with Space Engineer. Oh, there he is. Space Engineer. What's up, man? Welcome back. We were thinking that maneuver that it did this time was like 40 kilometers or something, dude. I don't see why this thing couldn't do 100. No problem. The flame is some sort of gaseous methane that is filling the entire payload bay. You could see it exit a second spot further down for a moment. I think it was the autogen lines again. Yeah, that's what chat's saying, dude. Yeah, I was just like, oh, there, speak of the devil. There he is. Yeah, I mean, there's nothing else up there. Like, it can't be the header tank. The header tank's kind of like, has like a skirt around it that connects to the nose cone, right? It can't be that. If it was, I mean, dude, if it was, they had some serious freaking burn through up there at the nose that should probably be addressed, because that means it punched through the outer skin of the payload bay and started burning the tank. Like, I don't think that's what's going on. So Raptors can RS-25 spraying. Yes, they can. Yeah, no other gaseous propellant up there. The COPVs are all nitrogen, and the headers aren't pressurized with gaseous prop. Each nitrogen, so something else is up. Yeah, there's only so many things up there, dude. A plasma lance? Yeah, exactly, Black. Like, that's highly unlikely, dude. If they were getting that, if there was a plasma jet up there that went through and punctured the skin and got to the header tank to cause it to leak, the nose of the ship would most likely blow off completely. That's clearly not what happened here. This, despite being a pretty large flame, is actually like a pinhole leak, dude. It's not big. It's not a big leak. Ace Frehley died? Oh, no. $74, that's too young. Damn. It sucks. What are you gonna do, dude? If any of the header tanks or downcomers had a leak like that, those engines probably wouldn't have even started. Yeah, no, it's something. Yeah, it's not burned through, I don't think. But it's interesting that the flames did come out the nose, which is very interesting. I'd be curious to see what was going on in that payload bay during landing. I mean, we know that SpaceX has the cameras from inside the payload bay, and you know they ain't gonna show us either. Shoot. You seen this? Ace Frehley died at 74. That's too young, man. Come on. You guys don't know who Ace Frehley is? Kiss. Lead guitarist for Kiss in the 70s. I mean, not that you should know that, but Kiss. You know the band Kiss? The guys, Gene Simmons, Paul Stanley, with the tongue. They do the tongue. Gene Simmons does the tongue thing. Apparently, Orion rollout happening later via Space Coast Live. Cool. Yeah, that sucks, man. Yeah, yeah. You don't want your pumps cavitating. Pump cavitation means everything's on fire that you don't want it to be. That everything's on fire that you don't want to be on fire. He moved his feet to Detroit Rock City one last time. I listened to Detroit Rock City yesterday. Or no, 2 days ago. I listened to Lick It Up today. Not Ace Frehley, but, you know. Everything's on fire if it's still attached. Yep. Pump cavitation is usually makes the turbine impeller or the impellers, the fluid impellers, very unhappy. Yeah, they would get very unhappy. So like I said, guys, whatever that is, it is a very, 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 very tiny leak. It's a tiny leak. It's not, this is like a pinhole leak, like maybe like the size of like the diameter of a toothpick. Because if it was any bigger, the thing would be not in one piece at this point in time. Now, something I did see somebody say this in chat, but it is something to kind of think about. That happens when they shut the third engine off. See, there's clearly 3 engines going right there. They shut one, and then watch. Engine shut off, and then the flames appear. Now, I don't know if that's just coincidence. I certainly don't see any flames there until they shut that engine off, so it could be due to chug. It could be a hydraulic hammer from shutdown. You think it's the angle and the lighting? All right, now I want to look. Hold on. Let's see the other views that we saw from the other day. It's this one. This is the guy. Okay. I don't see any fire. We still got 3 engines on because we got cones there. Let's see. Engine shut down right there. That's what engines usually fart like this when they shut off. But if you guys have ever watched like NSF, like you watched McGregor Live, you watched a Raptor test, they make a distinctive honk noise when they shut off, like sounds like a Wookiee or something. What's happening when that happens is you're hydraulic hammering all the plumbing. That is the sound of all the water basically, or water, all the commodities basically stopping instantly from them shutting the motor off. Yeah, the honking noise. It's a hydraulic hammer. Now they shut that thing off and okay, so let's watch this in slow-mo, dude. Ready? Can you repeat what they do? I'm sorry, I can't. It was only once. They make that noise. Engine's off. Here, let me turn the sound off. Sounds like a Wookiee is the best description I've heard of that. It didn't like that. This is the one. House. All right. I also noticed that when they shut off that's the top Raptor, when they shut it off, it did burp up a lot. Now, once again, that does happen. When they shut a rocket engine off, the impellers are still kind of moving a little bit. I mean, they're not, it doesn't take very long for them to shut off because valves and stuff. But long story short, there's residual commodities in the lines, guys. So there's always a little bit. It's like, you know, if you have a sprinkler on, you have your garden hose on, you know, your hose is connected to a sprinkler, you turn the water on, you know, the sprinkler starts going and then you shut it off. And if you took the garden hose apart, there's still water in it, right? Kind of like that, but with explosive stuff, right? No, with liquid fuel and so liquid methane and liquid oxygen. So when rocket engines do shut off, they usually burp. They fart out a little bit, and then they have some residual propellant dump. That happens. And the honking noise that we talked about, that is all the fluid, all the propellants inside of the lines going to the engine, stopping instantly. So I noticed that this thing actually, oh, hang on a minute. I saw something. Look at the jet. See that? See it over there? Uh-oh. It might be nothing. Is water hammering a thing with rocket engines? It absolutely is, Petrified, yeah. When a bit rich, it coughed up something. Now, that could be from shutdown transients because they're about to shut the motor off, or that could be the liner burning away. It's possible. See that? That's all the residual liquid fuel and liquid oxidizer inside of the engine. As the engine shuts off, there's just a little bit left in the lines and it burps it out. That's what happens. That happens. That's absolutely a thing. Liner burn would be green. I'm looking at what it burps out, Aqualex. Guys, my eyes are caca. What does that look like to you? It's like pink orange, I guess. Like, yeah. No, that looks right. I was gonna say it looks like it may have coughed up a little bit more, but so after combustion stopped, it is still leaking a little bit. You could still see a little bit of doo-doo coming out of it, and then it atomizes and it gets immediately burned off. See that? And it's right around that time that the fire starts. Ooh. Yeah. Yeah, that could be the throat. It could be the throat liner. It could be the combustion chamber. Something, guys, something funky happened with that thing right before they shut it off. It might be nothing. That could just be combustion instability. It does happen. I sent you a message on Discord. Oh, yeah? What is this? What's it say? Are all items circled holes? Not necessarily, dude. You talking about like those things? Nah, not necessarily. That's just, that could be a bladed, that's the crunch wrap, the wrap ablating off those dark areas. I mean, whatever's going on up there, that's a hole, because fire's coming out of it. Don't Raptors burn a bit orange as they deep throttle? I thought they go fuel rich at low throttles. I wouldn't adjust my mixture due to deep throttling, Aqualex. I don't think they have to because of the high chamber pressure. Could be wrong. Is that a vent at the top? Geek, that is not a vent at the top. I think the chug from shutting that engine off broke something up there. But the other thing is, I saw something funky with this engine. Watch the number 3. So that's the one that's on the top, the one that's back to the right. Did you see it? Right there. That. Yeah, that's not, I don't think that's combustion, like a combustion instability or something. Something's broken. That engine was about to break. It could have been from a leak, and it could have been from your mixture ratio going out of whack. You could get combustion instability running fuel rich, and we definitely know from the liquid oxygen that's kind of leaking out the side that there's definitely a LOX leak. But see, here's the thing, that's in the main tank, and you guys taught me yesterday, well, not taught me, I remembered it, but you guys reminded me yesterday that the engines aren't pulling from the main tank right now. The inlets going into the impellers on Raptors are T'd. There's a Y pipe. Looks like a Y exhaust, right? One of the pipes go up to the header tank and the other one goes to the main. That's the same color as the low throttle booster. Yeah. You think the top fire is related? Noctilox, I think they went to shut the number 1 engine off. Well, I'm using number 1 engine like it's the space shuttle. I don't know what the name of that engine is. I know they're using E1, E2, E3 for the inner ring, and then E4, E5, E6 for the vacuums. It's E1? Yeah, okay, so they do it like the space shuttle. All right. So the space shuttle, the top one was 1, 2, and 3. Or well, that's backwards. For you guys, it'd be 1, 2, and 3. So the number 1 engine is something funky has happened with that thing right there. I don't think that's just shutdown stuff. Something weird happened with it right during shutdown. It shut off, and then the hammering popped a leak up here. Now, interesting thing, right? The interesting thing. So, Space Engineer, you think it's the AP lines? Yeah, it could be the AP lines. The AP lines are going to depress, right? You're gonna see a drop in pressure, right? You're gonna see a shock drop in pressure, shutting one engine off on the autogenous pressure lines. Now, I'm just speaking because I know about autogenous pressurization. And chat or in Space Engineer, somebody let me know, like, what's the plumbing route? What's the route plumbing for the AP lines? Like, do the 3 combine into 1, and then like you have 3 for methane and 3 for oxygen, and then they combine into 1, and then 2 lines go up? I think that's what it does, right? So it's 3 and 3, and then they combine into 1, and then the 2 lines go up to the header tanks. Got it. All right. So if that's the case, right, you're going to see a shock drop in pressure on your autogenous pressurization lines going to the header tank, right? And now there might not be burn through from the heat shield up there, but I'll guarantee you there's heat inside of that payload bay. There's absolutely heat inside of there. Anything that's in there is going to get a little hot. The stainless is definitely going to get hot. We know that it tempers the steel. So a shock drop in pressure with stainless steel when it's hot is going to cause it to warp. It'll cause it to bing out of, like, it'll make that noise too. It could cause stuff to break. I'm not saying that's the definitive solution, but I think the AP line drop in pressure probably broke something, because it is absurdly hot up there. Like, you know, tile experiments aside, you're getting some pretty strong discoloration on the heat shield. The parts of the heat shield that are still there, it's very gray. See how gray it is? That's because the tiles kind of get scorched a little bit when they come through reentry. Tiles get a little scorched. They gray. That's what happens. They do burn a little bit. It's only after the first time. It's like Falcon 9. You know, when the first time Falcon 9 launches, it's white, and then it comes back down and it's kind of charred and sooty. Now that's for a different reason, right? That's not from reentry heating. That's from gas generator exhaust. Basically, it flying through its own exhaust plume. But same idea. If you look at the space shuttles when they first rolled out of the factory versus the space shuttles kind of after their second, third, fourth mission, the tiles do gray. It does happen. Now, because they're grayed a lot over there, that means, dude, there's a lot of heat in this nose cone. And I will tell you from what my limited knowledge of hypersonic understanding, that if Starship is re-entering at a 45 like this, that part of the nose where my mouse cursor is going to get insanely hot. The reason why is the same reason why if you look at the space shuttle's nose cone, so like if you have the shuttle right here, the space shuttle's nose cone is kind of pointed down. Not a lot of people realize that. Shuttle's nose cone is pointed, it's like the nose isn't a point like this, it's kind of pointed in one direction downwards. That's for the same reason, because they know that they put the nose cone where it was going to get the hottest. So that area is getting really, really hot. And if a lot of heat is getting introduced into that stainless steel, combined with a pressure drop from shutting the engine, oh yeah, it could make some problems. Look, space shuttle nose is pointed down. Not a lot of people know that. You would, or don't realize it. The reason why it's pointed down is because of that. You can see the nose is more flat on the bottom than it is on the top. The whole nose is kind of angled in one direction. That's designed to keep your shock away, as far away from the bottom of the vehicle as possible. But there's still areas where your plasma, so right where this line is where it gets the hottest. The closer that line is to your tiles, the hotter they're going to get. Starship up on its nose cone is doing something like this. But because Starship's nose cone is pointed up here somewhere, right? If you pictured kind of the shuttle with like a regular nose cone right here, what's going into the plasma? What's going to get hottest? Right? Right there. Right? Nose cone is like this. Plasma's coming at it. I heard the front fell off. Well, no, it didn't fall off. It was just removed from the environment. It might also see an increase. Raptor taps autogenous right off of the hot gas manifold. So if there is a bit of back pressure from the methane preburner shutting down, there could have sent positive pressure up. Yeah, exactly, Space Engineer. That's why I said it's a shock. It's either, I said a drop a couple of times, but it's a shock at the end of the day. It's just a change in pressure. It could go either way. I kind of talked myself through that one, dude. I was thinking about it. That's what I do sometimes, dude. I don't just sit here and report space news. I kind of think about it, and when I'm explaining it, the gears start turning, and I'm like, ah. So yeah, could be a shock in the system. I'll bet you it's just because the front got hot. Now, I know about hypersonics. Don't get me wrong. I'm not going to go build a reentry vehicle. I know a little bit about hypersonics from the shuttle, and I have a tile on my desk. That's pretty cool. I don't know. I don't think they burned through completely up here. but they definitely, dude, up there is definitely still really hot to the point where it might be like glowing red inside of the payload bay. Wait, the space shuttle featured a droop snoot? It was a fixed droop snoot, but yes. You have a tile on your desk? Yeah, oh yeah, yeah. It's pretty neat. Well, it's part of a tile. It's son of tile. It's kind of there. Son of tile. So, yeah, I mean that's the running theory. I think a shock drop of the pressurization lines blew a hole in the line. Now you got to wash your hands. Nah, I'm good. Is it edible? I wouldn't need that. Dude, it's almost immediate. It's immediately correlative. That's exactly what happened. They blew a fitting up there. Wait a minute. 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 Look right there. Right there. Oh. Oh. So is that payload bay on fire? Because it looks like it might be on fire. Oh. Oh, really, Rares? Nice. That's the second flame I mentioned. Whole payload bay volume is full of methane. Yeah. That little guy? I wouldn't worry about that little guy. Good enough for me. That's yeah, that's not great. That's yeah, that's not great, dude. They solved the flaps from melting. Now they solve the next problem. I mean, Luizo, that's really the truth, huh? So what do you think they would do to mitigate that? Guys, call me crazy. What would they do to mitigate that? Try not putting holes in your thermal protection system. Yeah, not putting holes in your TPS would probably fix that problem. that would probably fix things. I mean, I'm just putting it out there, dude. that would probably fix things. Which is why I think Ship 39 is going to have a full protection system. How tall is this thing? A 15 story building. Aurora. Yeah, 15 stories. Tiles, yeah, the tiles that did, the areas that didn't have holes in them seemed to have worked pretty well. Yeah, Baron, that's making a lot more sense now. I'm betting the first full one will be Ship 40. Well, they're also not tapping the pre-burner stream on... They're not tapping pre-burn stream on Raptor V3. They're taking feed and sending it through a heat exchanger. Oh, yeah, that helium heat exchanger. That's right. For the AP lines. Wait a minute. Whoa. Pump the brakes. Pump the brakes. Guys, there was a period of time where I just kind of didn't do space news. It was sometime like late during the pandemic where we just played games for a little while, and a lot of this stuff got black boxed to me. I was following the plumbing for Starship from like Starhopper all the way to like SN15. Like I could draw you the plumbing for that right now. But the newer stuff, I don't know as much. I haven't tank watched. I didn't tank watch a lot in 2022 and 2023. Sorry about that. Now, did you guys say that the AP lines are off the hot gas manifold? No, that they are. There's no heat exchanger on Raptor 3. It's a direct tap off. For V2. Yeah, for yeah, Raptor 2, Raptor 2, Raptor 2, Raptor 2. But the shuttle worked fine on the first try. Yeah. So they're pulling the AP lines off the hot gas manifold. So wait a minute. That means that those lines aren't pure gaseous methane. I mean, there is a possibility that you would get some, albeit very unlikely, you could get some gaseous oxygen mixture in there. It's not going to be 100% pure gaseous methane. I mean, it's unlikely, but it's possible. I mean, given Raptor's feed rates and chamber pressure, it's probably not, but the V2 and V3 tap the gaseous methane off the hot gas manifold, as well as tapping the gaseous oxygen after the oxygen turbine before the injector. Same on both. Dirty autogenous pressurization. Yeah, that's what I'm thinking, dude. So that means to an extent, you know, you could have an atomized mixture going through those autogenous pressurization lines. Ooh, that's the buoy cam over there. No, it won't be O2. It'll be water and CO2. Well, the point is it's not pure methane, you know, but that water could evaporate, right? And it could combine with the gaseous methane. I mean, if you evaporate water, it will atomize. If you turn it into steam, you could atomize it with methane. So the point that I'm getting at is that those lines aren't it's not pure gaseous methane and pure gaseous oxygen. It's kind of a combination of a couple of things, because it's the hot gas manifold. It's post pre-burner. Okay. How would you do in space refueling with no heat exchanger? You're flooding the main tank with water and CO2, brother. That's what I'm trying to figure out. Like, now I'm really confused. The conditions in the methane tank don't allow the nasty bits to condense into ice or liquid. Oxygen tank, it does condense into ice, which was a problem on the booster. Yes. The problem it's causing isn't burning, it's ice. Look, the AP line could have burst, because if you have an AP line that has ice in it that has evaporated, you could overpressurize the line and it could burst. And if it bursts, it's going to be energetic. And if it's energetic, then it's going to catch on fire. Do you see what I'm getting at? I understand it's ice. I'm thinking 2 or 3 more steps down the road. You're back there. I'm on third base. You're on first. Who's on first? But what's on second? That's the real question. Interesting. How are you going to deal with? Well, I know how we get it. They have mitigations. I'm really wondering, like, who's pitching? Yarg is. Economies of scale, like we talked yesterday. It's logistically better for them to remove the heat exchanger on the engine, which is complex, takes a while to produce and costs, and just designing the vehicle to compensate for the gunk. Hey, Admiral, 73 months. Thanks, man. Shirley Rocks had a 37-month resub in there, too. Thank you. Sorry, the headset went out because I don't have Starbase Live going. Clearly, the solution is Raptor 3. Okay, hold on. I need to look at something. I'm looking around for a plumbing design here. All right, this one's from NSF. That's Raptor 2, though. Yeah. Oh boy. Wait a minute. That's the cold. Huh. Yeah, that's tapping off the cold gas one. That's not right. That's not right. That's not right. Who did this one? We gotta always give credit. Inspired by Else Maslov. All right, let me take a look here. Yeah, right. All right, where's the taps? GCH4 to tank pressurization. Oh. Yeah, okay. Yeah, it's right. It's not just a tap off the pre-burner. Like, that's as hot as that gas is gonna get. I wonder what drove that design decision, pulling it off of the pre-burner. Because okay, this area right here, see this blue line, guys? So okay, let me explain. All right, so here's how Raptor works. Raptor is a full flow stage combustion cycle. So what does that mean? Okay, so the plain English way of saying it is that you have, picture two jet engines in your mind. Just two jet engines. One jet engine has a different mixture rate than the other. Now, what is mixture? Mixture refers to the amount of oxidizer versus the amount of fuel that you're getting. There is an ideal amount to make the most efficient combustion. Now, if you go too much fuel, right, that's called rich, right? If you go too little fuel, too much oxidizer, that's called lean, okay? In the middle is called stoichiometric. And stoichiometric is a very fun word to say, so I will say it one more time just for the kids in the back. Stoichiometric. Pretty cool, right? So, back to our two jet engines. You have one jet engine over here that's running extremely lean. And the other one over here is running extremely rich. The exhaust that comes out, because this one's running lean and this one is running rich, the exhaust that comes out of this jet engine is going to have a lot of oxidizer in it. It's going to have a lot of unburnt oxygen because the combustion was way too lean. The one on this side, the one on the right, is going to come out with a lot of unburnt fuel. Now, picture those two jet engines and they have their jet exhaust, and picture their jet exhausts meet, like have a funnel into a Y pipe, right? And there's an injector plate and that goes into a rocket engine. That's what Raptor is. That's what a full flow stage combustion cycle does. It's two jet engines, one burning really rich and the other one burning really lean. shooting their exhaust into a rocket engine. Crazy, right? That's why Raptor is nuts, because it is 2 jet engines shooting exhaust into a rocket engine. Now, why do you do this? Why would you do that? What's the point of that, other than it being really freaking cool? The reason why you do this is because the jet engine, remember, it's shooting out super lean, and this one is shooting out super rich, right? If you're able to actually spread out the air, the fuel molecules and the oxidizer molecules, spread them out, and then basically collide them into each other like a freight train, because they're more spread out, you have more, you're getting what's called better atomization that way. Because they're all spread out, you don't have to worry about fuel bumping into other fuel molecules and oxidizer bumping into other oxidizer molecules. They'll basically run at each other, and when they get near each other in the right pressurized, in the right low pressure environment, they actually kind of stick, like surface tension almost. Like, you ever see a water bug go over water? Kind of like that. They stick to each other. You get better atomization because you're using gas. You're using gases. Right? A carburetor does the exact same thing, for what it's worth. Yeah. A carburetor delivers fuel at low pressure into a venturi, so the fuel spreads out, combines with your air being sucked in from the air intake on a car, and then that goes into the engine and blows up. Right? Raptor's doing something very similar to that. But it's 2 jet engines shooting into the rocket engine. Now, in your injector manifold, right, the gases find each other, and more of your liquid methane, or more of your gaseous methane at this point, can combine with more of your oxidizer at this point. Now, that's basically what this diagram says, okay? That's what this says. The interesting thing here, the line we think that popped on the landing, that's an awesome picture. It's over, where did I put it? The line we think that popped on landing. See the flames right there? There shouldn't be flames. Tim Dodd always says the flames need to be coming out the bottom. If the flaming end is up, you got problems, and that still holds true here. Flames should not be coming out the top of this thing, right? If we go back over here, we think that this one, GH4, 2 tank pressurization, we think that that's the one that popped. But obviously, like, way up on the ship. Now, here's the thing. Your hot gas manifold. It's basic. The line taps off the hot gas manifold. See this sucker right here? It taps off that. All right? The interesting thing is that if you tap off this, remember what I said. Over here, this is your jet engine that's shooting out extremely fuel-rich gas. And over here is your jet engine that's shooting out extremely lean gas. And they combine in the injector manifold. Right? Great explanation. Thanks, man. I'm good. I love propulsion. I have that, like I said, dude, the book. The good book. Love this thing. It's not just on my desk as a decoration, I swear. Right? So you get gas to gas in here, and that produces a much bigger explosion. But right here in this area right there, you know, they have if you look, the GOX tap off right there. That's gaseous oxygen to tank pressurization, right? This is what keeps the tank structurally sound, right? It prevents the thing from crumpling like a soda can. It's interesting that they chose to tap off here, because now you're getting a contaminated mixture. It's not pure gaseous methane. It's gaseous methane mixed with an extremely rich combustion, which is going to get water, right? You're going to get water and CO2 build up in these lines, which is, we know that that's what they had. I don't understand the design decision behind doing that. And keep in mind, I like propulsion, but you don't see me doing this, right? Between tapping there and tapping over here off the straight gaseous methane line. Because another thing that Raptor does to assist with the fuel pre-burner and also cool the engine off is they take the liquid methane, right? It goes through your staged impeller right here. It goes through your main fuel valve right there. right? It goes down through here. And then remember how I talk about how Raptor has cooling channels in the liner on the nozzle? Those cooling channels flow the methane through it. And when the methane flows through it, it goes down and then it does a U-turn at the bottom, at the rim of the nozzle and comes back up, right? Because it exchanges all the heat, right? It exchanges all the heat with the combustion, right? It turns to gas. It just turns to straight gaseous methane. So this would be a much more pure area to tap off to recirculate the tanks with straight methane instead of a combusted byproduct here that's mostly methane, but it also has some other stuff in it because you introduced oxidizer to it. It's not pure. You know what I mean? Same thing with the GOX tanks. Now, Space Engineer, what are you saying? The reason it's kind of messed up like that was the attempt to locate it into a single common umbilical instead of having several connections everywhere around. Trade-offs, always with engineering. So, okay, fellas, here's the thing. I think that this happened because they punched a bunch of holes in the heat shield. I'm pretty sure that that's why that happened. Now, if it is propulsion related, it's possible. If it is propulsion related and the chug from shutting that engine off, because go back and look at this picture, your MFV, that's your main fuel valve right there. Notice that it's post-impeller, okay? So when the engine shuts off, it shuts the main fuel valve, and then everything that's downstream of this is what you see getting coughed up by the Raptor. That's all that flames that come out the bottom. And the reason why you want to know why they turn orange? They turn orange because there's more methane pipe than there is oxidizer pipe. Because the LOX pipe is directly on top of the combustion chamber in Raptor's design. So there's a lot more methane. So the thing ends up going fuel rich and then blowing that out the bottom. It kind of sneezes after the main fuel valve shuts. The honking noise you hear is from all the liquid methane that's flowing through here suddenly coming to a stop. That's what the honking noise is. Honk! Right? Better methane rich than engine rich. Bingo. Now, exactly, Jaka, that's the reason why they do this. That's the reason why the methane pipe is longer, because if you had your oxygen pipe longer, oxygen sucks at absorbing heat, first of all. And second of all, it would rust everything on the inside. Third of all, your engine, that heat would have to go somewhere and it would most likely go into your liner and break it. Yeah. The thing, though, is that we have never seen a Frosty Raptor nozzle. It's because they're milled channels that are inside of the liner, Black Eagle. Yeah, they're on the inside of the liner. Yeah, crazy. And also, there's a lot of heat being introduced into this system very, very quick. You're not going to see them. You're not going to see them chill down. Honk. Hey, Amadeo, $5 super chat. What books do you recommend to learn about spaceflight and rocketry? The one that, here we go. Amadeo, I got you. The one that I like the most, there's actually two. First one is Rocket Propulsion Elements by George Sutton, RPE for short. The second one is this one. Modern Engineering for Design of Liquid Propellant Rocket Engines by Dieter Heusel and David Huang. You want to learn about the stuff that I'm talking about here? This is a good book to learn it. You want to learn about tank ullage, gas generator systems, fluid impellers, hydraulic hammering, chug, jerk. Yeah, no, I'm not just saying, no, I didn't call you a name. Jerk is a thing, okay? It happens. And yes, it's when stuff stretches. Shut up. I'm serious. I'm not making a joke. I mean, I kind of am, but also, yeah, you do those ones, Amadeo. Those two, you'll be set for a good while. Now, keep in mind, the first one is Rocket Propulsion Elements, RPE by George Sutton. Now, hold on a second, though. This is not just some book that you're going to read and be like, oh, yep, time to make my rocket now. Dude, no. These books are college level textbooks. It would help if you passed some high school math courses, but there, look, I just opened to a random page. This is a lot of math. These books are the real deal. It's not something that's going to dumb something down. It's not an info video or like, it's not like watching EJ, you know what I mean? Or Tim Dodd or, you know, Space Engineers Post or NASA Spaceflight or anything. Or Marcus or Zach. It's not, this isn't infotainment. This is the real deal. So you really got to know your stuff with these books. I mean, I just bought them anyway, and then I started learning. I will warn you that that takes a long time. That takes a long time. But that's the real deal, man. That's the books. That's the books that they give to aerospace engineers. I know because aerospace engineers recommended them to me to read if I wanted to learn aerospace engineering. Weird, right? I'm rusty on my derivatives. Ugh. One of these days we'll dive into the math when I've either gotten out of the valley of despair or I've gone completely clinically insane and just decided that derivatives are fun. It's gonna be one or the other. Where in the valley are you? Let me bring up the chart. I would say that I'm somewhere over here. I'd say I'm somewhere in this area here. I am not up here. dude, even now, I'm not up here. I'm over here somewhere. I understand. I'm confident I understand what I'm doing, but the math part kind of... we're right here somewhere. The Valley of Despair, seeing Old Space lobbying to replace HLS. Dude, don't... Oh, come on now. If you think derivatives are fun, you are clinically insane. I'm telling you, man. I'm either gonna like get a concussion or something, or like just completely go bananas, and I'll just be like, "Chat, we're doing calculus today. Get ready, baby." Everyone's gonna be like, "I don't want to do this, man." I'll be like, "No, there's no getting off the calculus train." You know, like that's how that's gonna happen, dude. It's gonna work like that. But anyway, so here's the thing. Going back to the umbilicals and everything, right? Valley of Despair is believing in the Yankees. Yes. 2 + 2 = banana, size up, not 5. Okay, so here's the thing. SpaceX, with their propulsion department, guys, SpaceX is not, they're no spring chicken. Let me put it this way. There is a very good reason why they tapped off of the hot gas manifold, right? Instead of the gaseous methane, right? There's a reason why they did that. There's a reason why the tap is over here and not over here. And whatever that was, there's no way they didn't know that the trade-off, there's no way they didn't know that the trade-off there between tapping the hot gas for your GCH4 is going to contaminate your tanks. It's going to contaminate when I say contamination, I mean your tanks are not going to have liquid methane and gaseous methane in them. There's going to be contamination there. Not much, but enough, right? There's no way they didn't know that. So yeah, this design decision was because they were willing to deal with the trade-off. So that tells me that the trade-off here is negligible. The contamination in the line is negatable. That's not a big deal, but it is there because it's your post preburner combustion. For the person... Oh, yeah. For the person who hasn't seen a frosty nozzle, the heated flow. Yeah. The gaseous methane is on the outside. You wouldn't see it. You wouldn't see it. You would see the main fuel valve, nice and frosty. Or not the main fuel valve, the main fuel line. It should be nice and frosty. Yeah, it's not. Lovely. So that's the main fuel, right? There's your recirculation manifold. The channel goes down, it goes up, and then one of them goes up and comes down here. That's your hot gas manifold over there, and that goes up into this thing, and that's where it delivers it. That's your hot gas manifold. And Space Engineer, thank you for, I don't know if this is your diagram, but it's from your post, dude. So that's from January. But it's from your post. That actually clarified a lot of things. Oh yeah, it's a little frosty. She's a little frosty. She's just a little frosty. I mean, it ain't the LOX impeller. Look it up there, guys. That thing is completely frosted. The diagram says TSC on it. Does it? Bananas? Seeing the gimbal with Raptor 3 was pure bliss. I thought that was sped up, dude. Hey, chimp. 31 months. I thought it was sped up. I thought that footage was sped up. Space Engineer told me it wasn't. And, you know, like electric TVC, so eTVC makes a lot of sense. I cannot believe that that's that's real time. That is crazy. Because when you gimbal an engine, right, you're taking all of this that you see on the screen, you're taking all of that, and you're wiggling it around. That's crazy, dude. The other photos of it firing do have it frosty. That photo is just early on before it did. Yeah, so it's right after startup. Got it. Was the McGregor mystery structure venting an engine test? I don't know, man. That's a good question. Tolerances that this thing has is wild to think about. And all the temperature swings it goes, it's just wild. That's what, yeah, 619. Do you believe this? It's a triumph of material science and engineering. Like, that's bananas. And you're dealing with the gyroscopic effects of the pump. Yeah. Okay, Cyborg. Idiot question from the Aerospace 101, from the freshman aerospace student. In this design, one of your impellers is on the center line. The moment... Oh, no, you're still going to experience it's still going to have gyroscopic precession. I was going to say, does having one on your center line kind of negate that? But no. I mean, it might. I mean, if they have to be contra-rotating. They better be contra-rotating, or else you're going to put a lot of strain on things. The pumps counter-rotate to avoid most of the gyroscoping effect. Yeah. Okay. So if they're contra-rotating, right? It's the methane one that's going to give you a little. That's going to be where your difference is, because it's not on your center line for the engine. At what point does the engine gimbal? So on a Raptor, your LOX inlet pipe, see how there's bellows right there, nuclear? See how it kind of, those are called pipe bellows. Do you remember yesterday when I was saying that there's all kind of flexi joints in the plumbing? The LOX inlet line goes through the gimbal. It goes through it. If this wasn't complicated enough, it goes through the gimbal. You can't see it in that picture, but... Does Project Jarvis make sense for Blue Origin? Will they achieve their goals with it? I don't know. I don't know what their goals are. No good, to be honest with you, dude. Yeah, so you see there's also a flexi joint for your CH4 line as well. Is this a sea level engine or the vacuum engine? As far as I can tell, Zyzep, the vacuum engine is pretty much the exact same thing with different nozzle architecture. So your cooling channels are going to be a little bit longer, but that's about it. It's more or less the same. This is a sea level, yeah. They've been oddly avoidant of showing the gimbal mount on R3. Huh. Look at the pipe original closer. Is it not the pre-burner? What? So the methane, guys, we're looking at kind of the side of the engine comparatively to the diagram. The methane pre-burner is on the opposite side of the motor. Yeah, they haven't shown it. Interesting. Interesting. I can't believe it looks so simple, yet it's so complex. Yeah, Vert, it's because most of all this stuff is consolidated into one unit. Like I said, Raptor 3 is a mastery. Oh, it says Space Engineer right there. God, I'm stupid. I swear I can read. I swear. Raptor 3 is a mastery of fluid management. It is like Raptor 3 to like rocket propulsion is like what the iPhone was for smartphones. It really is that good. We tried to tell you that. I don't read. I do. It's good you can read because I can't. Yeah, that's what happens when you do too much math. No, not meth. Math. This is not meth. This is math. What the hell would they even upgrade for Raptor 4? My guess for Raptor 4 would be optimizing Raptor 3 around high flight cadence. That would be my guess. All that mess between both the pumps is within the valve housing. What's not shown in that graphic is the hundreds of different fluid lines routed around inside of the casing. Pressure transducers, pneumatic lines for valves, electrical lines. I'd love to see how it's all crammed in there. Yeah, me too, man. Me too. Don't we all? What a freaking thing, dude. And then on top of all that, guys, if if we're really going to just blow your mind, Raptor has hydrostatic bearings. They submerge the impeller shafts in the propellant. They're submerged in the propellant. That's what gets them to spin so fast without cavitation. Yeah, hydrostatic bearings. That's the other reason why they could spin so ridiculously quick. Yeah. Dude, it is. It's no joke, man. This thing is no joke. That thing's the real deal. Like I said, the iPhone of freaking rocket engines. Not, I know there's some people like, but Android. No. The iPhone introduced the whole smartphone thing, like that. Dude, this thing is on another level. It's unbelievable. Crazy, man. Anyway, there's a little bit more space news. Space Engineer, thank you for letting for the diagram, dude. I always give credit where my diagrams come from. Just in case, give credit where credit is due. Ignoring BlackBerry. Yeah, because every phone looks like a BlackBerry now, right? Last for animation of the Raptor gimbal. Oh, nice. Yeah. Crazy, huh? There is a little bit more space news, but yeah. Crazy stuff, man. So here's something from Eric Berger here. He's saying there's some chatter out there about damage to Blue Origin New Glenn, the Blue Origin New Glenn rocket. Reality, there was minor damage to the second stage during transport, but it's not expected to significantly change the timeline. I still think that November 9th is a reasonable target for escapade. Escapade? What is it with people dropping spaceflight hardware? What is up with that, dudes? I mean, Blue has plenty of second stages lying around, so I don't think that's going to be an issue. Just use the other one. Bro, I sat down at a Blue info session and opened up Twitter before the event started, and this was the first tweet I saw. Whoops. The bearings are one of your favorite parts. Collected wreckage from debris in the mudflats has told me some insanely small details. They tap off a tiny bit of hot gas on the leading edge of the stators after the turbine on both pumps, which is directed inside towards the turbo shaft. Said gas is used for axial balancing of the shaft. It may also be used for the thrust bearing at the bottom of the oxidizer shaft. I mean, they would have a thrust bearing because that thing is going to want to go up. That's for sure. Huh. Okay. Okay, dude. Sure. Yeah, just do that. Right? Just do that. Okay. Here's where I got that Raptor 3 would do a heat exchanger to eliminate the icing. Is this from one of Zach's videos? All right. What does Zach say? We won't watch the whole thing because I want you guys to go watch CSI Starbase. So if you're intrigued by this video, follow my boy. He's a good dude. This is CSI Starbase. This is Zach Golden. He's pretty damn smart. He's smarter than me, dude. That's for sure. All right. What is he saying, Aqualux?
On this topic with the everyday astronaut, Elon mentioned that Raptor 3 will have a highly complex integrated cooling system built into the engine. While he didn't elaborate on this topic as much as I would have hoped, I think there is a chance this might end up eliminating the autogen contamination problem. Even though SpaceX has finally shared a few images of the new Raptor 3 during recent static fire testing at McGregor, there isn't enough to go off of to help us figure this out. The most we can really get out of this is knowing what parts of the engine are frosted over during operation. This kind of helps determine which components contain cryogenic liquids versus hot gas. Unfortunately, there is nothing visible that would help us identify which fluid is being used in this new cooling system. That happens to be a very important detail. We can safely assume that, like Raptor version 1 and 2, liquid methane is used in the regenerative cooling circuit for the main combustion chamber and expansion nozzles. But the rest of the engine is still a mystery at this point. One of the goals for
Here, I'll link up the video in both chats if you guys want to go check out CSI Starbase. Now, okay, fellas, you guys are talking about heat exchangers to prevent autogenous pressurization contamination, right? We're talking about heat exchangers here. You know, we know it's not on the engine. I think it's safe to say that there's no closed loop helium heat exchanger on Raptor. I'm pretty sure there's nothing like that there, right? Now, with that all being said, dudes, do you think they would put a heat exchanger somewhere else? Because no, that doesn't really make sense. Where else would you put it? There's not even helium on it at all. Eliminated. Yeah. Where are you going to put a heat exchanger? Like, where's that going? So it's not on the engines. So you're going to put it before the engines? You can't have, dude, like, yeah. There's this, SpaceX has a solution for it, clearly. I know that they have a solution for it. Like I said, just watch it for a while. I know they know how, that there's something. We're missing something. And we're missing something not because we're bad at, like, trying to figure this stuff out. We're missing something because SpaceX doesn't give you all the information on purpose. They don't need everybody knowing how their trick stuff works, you know? Think about this one, though. No. No, that doesn't make sense either. Do you think it? Okay, I'll put it out there. I know the answer is probably no. I'll put it out there. So, fellas, do you think that they're going to move that component somewhere else? So, what could you do to get contamination out of your AP lines? What could you do? Putting it through an exchanger to boil off the steam or something could do it. Do you think that they would do that with a fluid transfer system? So the system that they're using to, whatever they're going to use for in-flight refueling, right? Do you think that could remove the contamination? Because you got to think about it, right? Like, no, that doesn't really make sense. Well, if Starship is going to be flying on an hourly basis, it's not going to stay up there for very long. So that means it's not a lot of time with contamination in your autogenous pressurization lines, provided they don't, leak and explode and catch the payload bay on fire. That's kind of important that doesn't happen. In-flight refueling could be a way to deal with it. Or they just said, frick it. I mean, Space Engineer, you said they just said, frick it. They could have just said, whatever, no problem. Whatever, if it gets contaminated, we'll decontaminate it when it gets back down here. But where my mind's going from there is that, okay, what happens when you're sending one to Mars or the moon? Well, the moon, you don't have header tanks, so I don't think they have to worry about that. What happens when you go to Mars and you land one out there? What happens? You're just gonna have contamination in the lines? Like, They drain the booster straight back into the tank farm after catch, so they have some way to filter out the contamination ground side. I assume there's an operational method of decontamination, like venting to vacuum. Yep. Venting to vacuum, though, would cause solidification in the lines, though, Phil. You would solidify any water you had in there. Couldn't they flow hydrogen or helium through the line to purge it? There's no helium on Starship nuclear, and there's no hydrogen either. There's methane, which has hydrogen in it, but how would they make more gas without lighting the engines? See, these are some interesting questions, Mill. You could use gaseous methane. You could use your gaseous methane and gaseous oxidizer in some form of a combustion pump to move propellants around. ULA actually experimented with using an inline 6 that ran off gaseous hydrogen and gaseous oxygen. Yes, an inline 6 internal combustion engine. And that would have been used to repress tanks on a, like, it bolted to the back of a Centaur. That would have been used to repressurize your tanks and also could be used as your fluid pump. All the decontamination is left in the bottom of the vehicle. Ice is drained out the bottom of the dome, and other contamination that is not ice is cleaned out later. The Roush engine, yep. Elon wants to move as much to ground side as possible. I think they will filter it after landing before refilling, both on Earth and on Mars. The cooling passages on the combustion chamber and nozzle are heat exchangers. Are your heat exchangers? Yeah, Todd, for sure. But what we're talking about is the GCH4 tap off is your hot gas manifold. It's not off of the heat exchanger, which is very weird. It's a very weird way to do that. I can't figure out why they want to do that, because then you're running contamination in the lines. If you look back at the diagram, the autogenous line taps off just before the preburner and is used to cool the preburner. At least that's how the diagram looks. Yeah, Resi, it's post-combustion though, so you're going to get contamination in it. The regen channels do not get hot enough to be effective auto gas. Yeah, okay. Do you think we'll see shipments of Raptors going to Mars in case they need replacements? On starships, Tistry, yeah, probably. Probably have a couple of spares. We got to remember, Tis, the other thing is that starships should, with an empty payload bay, you won't need 3 Raptors to take off from the surface. As long as your vacuum engines are fine. But I'm pretty sure you could probably get home with 2 Raptors, 2 sea-level Raptors from the surface of Mars, provided you had the propellants. Yeah, I'm pretty sure you could do that. Engine out capability throughout the entire phase of a Martian exploration mission would be really preferable. Dude, I can't believe we're talking about this. I can't believe we're talking about this like, this sounds like the same kind of stuff we do when we theory craft like the Apollo applications program, right? Like, oh man, the Apollo applications program would have been so cool if they made another Skylab, or if they never stopped launching the Saturn V, or they had highways on the moon with lunar rovers going up and down. Like, we talk about where the Apollo program could have gone, but we're talking about a space program that's unfolding in front of our eyes and actually is possible. That's cool, man. That's cool. Remember, gas expands when heated. You could only make the channels so small. Yeah, exactly. You have to deal with the thermal expansion. Man. Hey, Louie, what's up, dude? Hey, how you holding up, man? Everything good? What the actual frick, man? Somebody gifted Louie sub. How's your mother? How's your mother? I don't freaking believe this, dude. It's always somebody. Can you look at my last? I was thinking about it the other day. Does that even work? What's up, Mill? What's up? What's on your mind? Could you only flow methane and oxygen without cross-feeding to the other and heat them up with the torch igniters? Conceivably, yes, but that plumbing would be more complicated than Raptor 1. But yeah, sure. I mean... The other thing is that I don't think Raptor has torch igniters anymore. I'm pretty sure they removed that from the design. I'm late. What's blowing EJ's mind right now? Cerebral here. I'll clue you in. You'll have a cerebral malfunction after seeing this. Ready? Don't you love complexity by simplification? Yeah. Yeah. Nice and round. Yep. And some of those freaking Raptors blew the cooling channels open on ignition because the nozzles were bent. Can you believe that? How did they not blow up an engine? How did an engine not explode? How is that possible? So, guys, some of these engines they didn't take them off. 24 of these Raptors were flown on Flight 8. Was it Flight 8? Yeah, it was Flight 8. So some of them on the way back down, they got too hot when Super Heavy came through and re-entered, and it actually warped the nozzle. And they fired them with warped nozzles. On Flight 11, they fired them, and they didn't break. No problem, Louis. How did that not explode? How did it not explode? You're impinging your freaking cooling channels. How did it not pop? What the actual frick? From the diagram, it very clearly looks like it taps off before the preburner and uses regenerative cooling to make sure it's gaseous. Look at the color gases on both sides of the burner. Well, Resi, I'm not disagreeing, but SpaceX very clearly admitted to problems with contamination in the AP lines. They said that ice was building up. So it had to have been contamination. I thought they admitted that. That's why I'm like, no. You know? I mean, I see the diagram. You're not wrong, but I don't know. Maybe we'll have to go look. How did one of these just not explode? We're looking at Raptor 3, not 2, right? Yeah. Cooling channels may be in parallel. They're not in parallel. It's cold. Dude, this isn't anything I didn't know before, but this certainly was a huge refresher. And really kind of reiterated the point that Raptor is disgusting. That motor is disgusting. Like, disgusting. And I mean that in a positive way. It's gross. That is a gross abuse of physics. You got it for me, Dr. Lex? Let's see. What you got for me?
Planned to be
what you got
the
there,
final
band?
launch of this version of Starship, version number 2. Right now, we're actively building multiple next-generation V3 Starship and Super Heavy vehicles.
How do the warped engines not unwarp during the second static fire? I don't know. Reactions. This is what's blowing my mind. Skip ahead a little. You know what? I'm just gonna sit here and look at this V3 render. This was from the cast, XJ. What's this stuff? Oh, those are the umbilicals. All right, I'm stupid. It's kind of scary. XJ, do you get the same uneasiness, like, looking directly, like, I know it's a render, I get it, but, like, I've stood behind rocket engines looking at them like this before, and I get the same kind of, like, uneasiness, like, as getting flagged. You know what I'm talking about? It's like, you're looking down the business end. I'm like, okay, I don't want to be in front of this. I don't want to be in front of this, man. You know? I don't want to be here. This is bad. Like, danger, like uncanny valley, like something is very wrong horror movie. Like, okay, we should not be here, you know? I hate standing behind engines. Okay, all right. It's not just me. I mean, space it, yeah, dude, don't get me wrong. I'd go up there, look once, and I'd be like, okay, I'm never doing that again. Getting flagged from an empty gun. Yeah, Pop, exactly. I don't like being flagged. Not even with, like, a Nerf gun. I'm like, stop. Don't do that. Is this Danger Dune? No, it's not. Danger Dune's over there. The remote camera set up for... Where's the SQD? There's no... The remote cameras from the first Block 3 flight right here are going to give off some serious Saturn V vibes. Standing behind the J58 at Pima made me uneasy. All right, you're just like, they forgot. Yeah, there's no SQD in the render. What the hell? I need a human for scale. You want a human for scale? In this picture, my mouse cursor, if I was standing where my mouse cursor is, that'd be about as tall as that. Yeah. Source, I've seen this, albeit not in this state of construction, but yeah. The mouse cursor would, you know, the mouse cursor, that's probably about the size of a person. Yeah, that I'd say that's pretty accurate. It's pretty close. Starship's huge. Starship is huge. It's go and see it, guys. Go down to Starbase and look. You see for yourself. It is absurd. On Flight 8, the first day I got down there for Flight 8, Booster 15 rolled out to the pad. The last day I was in Boca Chica, Booster 15 rolled back from the pad. I've stood about, I don't know, 2 to 3 meters away from a super heavy booster. Holy crap. It was dark out when they moved it back. I couldn't see the grid fins. They were in darkness. That's how high it was off the ground. I looked up and I'm like, you can barely see the grid fins up there because it's a 22-story building. Yeah, the booster is 22 stories tall and the ship is 15 stories tall. Will you go for the first Block 3? I want to, and we'll just leave it at that. We'll see what happens. In Leicester, there's a National Space Museum, and it basically has a cafe that's got a Saturn V booster business end in the ceiling. About every 5 minutes, it's starting to rumble and smoke, and a machine turns on. They have the F1 engine. Yep. It's not a monetary thing, spoiled. You guys understand, and this is what I mean about theory crafting out this space program. You understand that this is next year, right? This is 6 months away. And I know people are like, oh, 6 months away. No. This is something that needs to happen because of HLS. This is soon. A ship catch is 4 months away, according to Elon. And, you know, I get it. Like, if you're going to say, oh, what about Elon time, EJ? Yeah, you're right. But also, guys, SpaceX doesn't want a stopgap. They want to ramp up, not ramp down. If anything, this year was the ramp down, preparing for Block 3. I'm winning my bet orbiter refueling by 2027. I don't think Flight 12 is happening this year, Hellfish. I think it's going to be January, February, and I think a catch will be March or April. Tubes. Good scale. Dude, yeah, I saw this post the other day. I want to see that Raptor firing, Noctrolux. Just give me 1 second. I saw this post the other day. Somebody posted this up on X. That is that's 2 scale. So that's an A380 on top of with a 737 on top. I don't think V3 will explode, Hellfish. You're much more likely to have something on the ship go wrong. His timing is feeling more punctual. Well, as you get further into development, Tron, the deadlines will stop being far out. They'll start getting more accurate over time as the design gets honed in. We'll be lucky to have a successful orbit in 6 months. 4 months for Block 3. Another 2 to work out the kinks. then another tube for a catch, and we might see an attempt of a propellant transfer at orbit. So 8 to 12 months is way more likely. I'll give you that one, Blaze. It was a little bit of hyperbole on my part, I'll admit. But the point is that that's happening sooner than you think, right? You know, we always look at the future of the space program and be like, yeah, that's 5 years out. That's not happening soon. 8 to 12 months is nothing in space flight time. That's nothing. That might as well be tomorrow. Did you see the photo of the prop transfer test hardware from Blue History? Yes, I have. Yeah, that's a 737 with an A380 behind it. That's Starship size. It's freaking huge. Like, I can show you pictures. I can show you everything. It's hard to discern the scale without having it right in front of you. I've seen it right in front of me. It is ridiculous. Also tubes. That's the Block 3 booster transfer tube. It'll feel like tomorrow when we get there. Yeah, all right. Tube. Look at the bellows. I never noticed that. Look at the bellows on that dang thing. That whole thing flexes. Holy tube. Because it's got a hole in it. Look at the flex joint. You gotta be kidding me, man. Flex joint's bigger than my truck. Yeah, look at the dude just standing down there. Don't get me wrong, guys. It's not that like I've never seen a flex joint that big. We've made bigger baffling and stuff for like ground side stuff. The point is I've never seen a flex joint that big being used to like launch something into space. That is an incredible piece of infrastructure for it's an incredible piece of infrastructure for what it is. Like, for something that large to be in the space program is absurd. Weird flex, but okay. Wait a minute. Does the avionics harness go through the strut? Holy shnikes, it does. What? Look, the wiring goes through the struts. How did I not notice that? Yes, they do. You hate it? You don't like it? That's cool, man. Dude, whatever. Does that mean the strut is hollow? To an extent, yeah. I mean, most struts are. Like, you don't need to make it a solid tube. I mean, and remember, it's about low mass. It's got to be as strong as it possibly can be and as light as it possibly can be. Yes, they do. I hate it. I didn't notice that before, but I mean, that makes sense. You're not going to put a raceway up through here. Hot staging will blow it away. Yeah, exactly, Phaedra says. Yeah, dude, exactly. You typed that before I said it, man. Dude, look at the beef. They thickened up the dome of this thing. Yeah, it's got a little bit of armor plating up here, considering what happens right in this area here. It's like they're rocket scientists or something. Yeah, I know. It's crazy. And this all was welded internally, which is very interesting. They welded all this stuff on the backside of on the inside of the dome. There's tack welds there, and there on the edge, but most of this gusset welding was done from the inside of the booster out. That's why you see burn marks and not welds. See the burn marks? The burn marks indicate that you got good penetration on the weld, meaning that it welded all the way through, which is what you want. But the vast majority of these gusset marks, A, they look like they were done by hand, which is still cool, which is really cool to me. And B, yeah, they were done on the inside, which is weird. This right here, these the consummate V's. I said consummate V's, chat. That is seam bracing for the tank. You saw one of those in the previous shot. That thing. It's that thing, but on the inside. It's basically they stitched it together to hold the seam better. Yeah, MCRS and Aqualex. So, Resi, are you over in Resi, you still over there in YouTube chat? Because Twitch chat just kind of came to the same conclusion. You might be right, buddy. You might be right. And if it is, I'm wondering where they're getting contamination in the AP lines, but you might be right, dude. I heard constipated bees. Yeah, I bet you did. Transfer tube is the same size as a Falcon 9. I know, dude. Isn't that bananas? Yeah, yeah, dude. You might be right, dude. It might tap like right before the preburner. It's possible. And you said that would, you're right. It could regeneratively cool the burner as well. Like if that's what they're doing, holy crap, that's trick. That's hot rodding, man. That's really cool. This stuff's so freaking... Oh. Excuse me. Okay. That was freaking real time, dude. You've got to be kidding me. It looks like it's sped up. It looks fake. I mean, I know it's not, but
moved inside. Our McGregor teams built some additional stands like this one, which essentially is the bottom of a super heavy booster. Lets us do gimbal or steering tests. So that's been...
It's directly below it. Check your Discord. Yeah, but sorry, this ended up being a Raptor deep dive. Dude, no freaking way. Damn Discord compression, hold on. Yeah, baby. Yeah, Rezi, you were right, buddy. Good call. There's a Space Engineer's diagram, by the way. You can tell because of the way it is. Kevin, not sure you heard the PA called that at KSC press site earlier, announcing the Artemis 2 Orion rolled to the VAB tonight. Killer. That was what you previously mentioned. Yeah, you were right, Darkroom. You guys were correct. I was wondering, like, that didn't really make a lot of sense, man. Tell it's TSC because it's really good. You ain't wrong. Dude, all those stupid freaking valves. You gotta be kidding me. No, gotta go a little bit more. Sorry, you cropped it by accident. A little further. A little further. Nope, too much. Ding! Oh, not exact. Ah, there we go. Good enough. Orion rolled to the VIB. I thought the U.S. was in government shutdown. Well, it hasn't happened yet, Lemon, and some operations are critical operations, time sensitive, like a moon race. They're still working. Yeah, it's the critical workers. NASA didn't really. Some NASA shut down during the pandemic, but not a lot. But yeah, the Artemis program's still going. Yeah. Now, whether people are getting paid, I don't know. I'd have to ask them. ISS ops too, because humans. Yeah. Here's the newest look inside a Star Factory. What do we got? Oh. I'm just gonna mute it. That NVIDIA. That's Mr. How's it going? Good. How's it going? That's Mr. NVIDIA right there. That's who that is. He's Mr. NVIDIA, like Mr. AMD. All right, what can we see? I'm scoping and I don't care, and it's weird and I still don't care. Yeah, it's Jensen Huang is the guy's name, but yeah. Nose cones. No. Oh. Damn it! Yes. Metal and stuff. I'm seeing half completed nose cone there. Maybe 3 right there. John NVIDIA himself. Here, Elon, I got you a Bach. No, that's a DGX, I think. It said it on the side. I don't know anything about these things. That's kind of cool. All right, that's kind of cool. That's also kind of cool. It's a machine to self-host low language models. So, all right, Cirrus, you speak software nerd more than I do, I would say. So you would want clusters of those things in a gigantic honking data center, right? Am I understanding this correctly? I'm pretty sure that's right. Yes, first ever rocket launch is Starship. Can you believe that? What is Chun Wang? What is he cooking? What is this? What is this? So this is Chun Wang. He is the guy that flew he commanded the, well, not commanded. He was part of the From 2 mission. First humans to ever go into polar orbit on a Dragon capsule. What is this? I've noticed that Starbase seems to have not evacuated for launches anymore. Lots of employees on site for the last 2 launches. Yeah. It's for home-ish use. Big data center just use thousands of graphics cards instead. Yeah. Okay, so seriously, maybe. I don't actually know a whole lot about them myself since I just heard about them, but I wonder if it's something they could put on a rocket so AI is on the rocket itself. I don't know. Well, okay. All right, cool. Wisp said that it's home-ish use. That's kind of cool. All right, 2034 Earth, Venus, Mars opportunity looks promising. 10 to 15 on-orbit refueling operations may be needed to make a crewed ship full. Most can be done at an altitude of 180 to 200 kilometers, made possible by Starship's size. The final refueling may be performed at a higher altitude of 2,000 kilometers, just below the Van Halen belts. Earth departure on August 21st, 2034 from a 2,000 kilometer orbit. Transvenusian injection burn of 3.7 kilometers a second will place the ship on an Earth-Venus-Earth free return trajectory. Venus flyby is expected on December 19th, 2034, 120 days after departure, 2 weeks before the encounter. If the mission proceeds as planned, a 25 meters a second maneuver will shift the trajectory from Earth return to Mars bound. If not, the ship will free return to Earth in September of 2035. The Venus Gravity Assist will send the ship into another Earth free return trajectory with Mars flyby around June 2nd, 2035. 1 week before reaching Mars. A system health check will determine whether to commit to Mars orbit insertion. If it's a go, a small 10 meters a second maneuver will put the ship to less than 100 kilometer altitude, perhaps. Periapsis. So that would be Martian periapsis, which is, I forget what that's called. That's stupid of me. Anyway, otherwise, a Mars flyby will lead to Earth and return in May of 2036. The ship will enter the Martian atmosphere at about 9.4 kilometers a second, performing an aerobrake to slow to 4.88 kilometers a second and capture into a 100 by 140,000 kilometer 7-day period high elliptical orbit. At AP, the 50 meters a second plane change will align with the inclination for Mars's equator, followed by additional aerobraking to remove about 650 meters a second of velocity, placing the spacecraft in a 120 by 6128 kilometer orbit. A 550 meters a second burn at 6128 will then adjust the trajectory into Phobos' orbit. The ship will stay at Phobos for 7 days. Mars Phobos L1 is only 2 miles above Phobos' surface, and Mars would dominate nearly half the sky, appearing about 80 times larger than the Moon from Earth. The ship will depart for Deimos afterward. 2 burns totaling roughly 750 meters a second will transfer the ship from Phobos to Deimos, and the ship will stay at Deimos for 7 days more. From Deimos, the ship will raise its apoapsis to form a 20,000 by 140,000 kilometer altitude 7-day orbit, requiring about 420 meters a second of delta V. At apogee, a 50 meters a second burn will adjust inclination and lower periapsis to 500 kilometers for final TEI, trans-Earth injection. If time and propellant allow, the orbit can be aligned to a polar inclination for Mars ice cap observations before departure. A trans-Earth injection burn at a 500 kilometer altitude requiring 1.5 to 1.6 kilometers a second of delta V in early July of 2035. If departure on the first day is in July, Earth arrival is expected December of 2035. If missed that window, a Mars 2036 arrival may be more feasible. Nominal mission duration, 490 days, with 30 days in Mars orbit and 14 days at Phobos and Deimos. 2 planets, 2 moons. For 7 kilometers a second delta V, which is pretty much in line with Starship, a fully fueled Starship and Leo's delta V. That's pretty much right. Yeah, that's badass, dude. That is freaking badass. Oh, do it, man. Freaking do it, dude. Take me with you. I'll go. So MCRS, yeah, like I get it. He's just theory crafting out a mission. I understand that. But also at the same time, that guy has money, so he can make it happen. You know, I know he flew Dragon into a polar orbit. So, he can theory craft all he wants, my dude. Dude, Mother Trucker can theory craft all he wants. Do it. Do it. Do it. Do it, bro. Please. Please do it. I want to see that. Dude, please, I'll go with you. You know? That, I mean, it would work. Yeah, so what he's doing is using gravity assists. There's a he has an animation of the of that mission. Look. So you grab assist off of Venus. Venus will shoot you out with an what's called an outward ejection angle. Right? And you basically get it so your Venusian ejection angle in this capacity puts your aphelion or highest point in solar orbit basically at Mars's altitude. That requires see how the ship is kind of coasting, and if it kept coasting, the high point of its orbit would be right around here. If you want to have the most ideal transfer, and you guys will learn this once we get further out into the solar system in our KSP career mode save, the most efficient thing to do would be to just kind of have your orbit get to right where the planet is going to be and have the planet fly by and collect you. Watch the dot when it gets collected. Ready? Whoop. It'll just sit there. If you do that, right? If you do that, you can use a minimal amount of delta V to actually circularize around the planet. That's maximizing the planet's gravitational pull for your mission parameters. This is trajectory optimization 101. And then, yeah, bounce back, put you right into trans-Earth injection, and you're back. So aim for Eve from Curvid and let Eve grab assist you to Duna. We would need some serious mission planning, Nova. Our timing would have to be perfect. But yeah, you might not be able to do that with KSP's solar system, but we could plan. I mean, we certainly try. We could plan missions like that. Sure. That's cool, man. You do it. Freaking make it happen, man. Oh, and for what it's worth, guys, there's a reason why I spent a lot of time dialing that stupid capsule in. I have a plan. Don't worry. So no Mars orbit. Yeah, it's technically in Martian orbit, Lemon, because it goes to Phobos and Deimos and loiters around Phobos and Deimos. It doesn't. It enters a Mars orbit, but it's what's called an eccentric Mars orbit. Eccentric means that it means that the orbit is elliptical. It's not like perfectly circular. Would you say it's the greatest plan? Evan, you know where I'm at, dude? The fact that somebody's even theory crafting this out is cool. I'd be wondering about Eklis constraints at that point, because that starship is up there for like 2 years. Environmental control and life support. Like, can that thing carry enough oxygen? Can you carry enough life support to support a 2-year duration mission? That's much, much longer than what you'd need to... That's much longer than what you'd need to do to, like a Mars transit. A Mars transit wouldn't take very long with Starship. The refueling would take a while. Like, well, not a while. The transit could be like 3 months to Mars. And if I was SpaceX, I would optimize that around. I would optimize life support systems around the transit time, right? This is quite literally a once-in-a-lifetime trajectory. Not only does it put you on an amazing path, it gives you escape routes. It just makes me curious how you'd keep cryogenics for 400 plus days. I would, Steve, yeah, that's a good question, dude. I'm just going to go ahead and assume that SpaceX has boil-off solved in the next 10 years. And just kind of leave it there. There are some really, like, we wouldn't be able to do this mission right now, but we could do it in the future, which is super cool. How do you keep cryogenics for a landing, flip, and catch? Well, the plus there, no good, is the header tanks. The header tanks are vacuum insulated because they're inside of the payload bay. So the payload bay acts as your sun shield for the tanks. If you took those header tanks and you wrapped them up in some MLI on top to basically minimize conduction from the thermal protection system, for instance, sitting in the heat, you could mitigate boil off pretty damn well, actually. Yeah. Yeah, I'd be wondering about life support, food, etc., etc. 2 years worth of food on the Starship is going to not, it's not going to be an inconsequential mass, you know what I mean? But then again, if Starship can move 100 tons into low Earth orbit and then get refueled a bunch of times, I mean, you could carry 100, all you'd need to do is be able to move 100 tons of whatever. That should be enough. I mean, you'd have to load that thing down with oxygen tanks and food. But now that I'm really thinking about it, you have the pressurized volume to do it. It's 1,000 cubic meters. You have the volume to get that done. Boil off for the main tanks is very difficult, if not impossible. Headers can be heavily insulated, and those are the only ones that truly matter. Main tanks will be periodically repressurized using a gasifier, which takes a small amount of reserve propellant, burns it, and dumps it back in to maintain pressure, so at least it can be retained. Yeah, the gasifier. Yep. Yeah, you got to main. So throughout Starship's entire flight, guys, on like a Martian transit, you have to, space engineers, right, you have to keep those tanks at pressure. You do not want high delta P inside of your tanks. That could compromise structural integrity and cause leaks in other things. You don't want that. How many people? I mean, Phaedrus is, I don't know. Okay, so me theory crafting this mission out, 6 people, 7 people, 8 people, probably be fine. 100 tons, let's say 100 tons, let's say 30 of that is all the crew paraphernalia, like bedrooms, sinks, plumbing, showers, stuff like that. I mean, you'd need water. You'd have to take water with you. Let's say 10 tons of water, right? So we're at 40 tons, 30 tons of crew paraphernalia, 10 tons of water, maybe 20 tons of food. So we're at 70 tons, 30 tons of life support systems. You could do it. Sure. That's that. I mean, you'd have to design it, right? But that's enough. That you could fly for a long time. I mean, those are just, that was completely out of my tail estimations, right? But like I said, the Starship isn't landing anywhere. You know, and the majority of your delta V gets on this like crazy gravisis trajectory thing, guys. The majority of your delta V is used right at the transvenusian injection, right at the beginning of the mission. So the header, you'd use the header tanks to fire those engines for the rest of the time. The hardest thing from there would be trans-earth injection. But at the end of the mission, that would be tough. Because, yeah, you would be scraping the bottom of the barrel at that point. I was thinking a crew of 3 for these first missions. Would they store or jettison solid waste? I would use it. Use it to make fertilizer so you could grow more plants or something with hydroponics. Martian style. Or just jettison it. I don't know. Depends. That's what getting me. The crude section is 10 tons at least, let alone life support. I mean, but Steve, this is what I'm talking about, dude. You have 100-ton to LEO payload capacity. 100 tons to LEO. Dude, if you can't figure out a 2-year loiter on orbit, if you can't figure out the consumables for being in space for 2 years with 100-ton payload capacity, you shouldn't be an aerospace engineer. You know what I'm saying? That's a lot. 100 tons, man. 100 tons. Would it be possible with that trajectory to send a tanker to Mars to refuel the crude ship there? You would need some kind of sun shield around a depot ship, Rockets. I don't think SpaceX, at least initially, is going to plan for that kind of spaceflight architecture. I really think they're optimizing around going to Mars and back. I budgeted 30 tons for the crew section. Space engineer. Yeah, it's 30. It's gonna be a lot. You gotta have beds. You gotta have, you know, plants, batteries, you know, tables, chairs. I mean, maybe not chairs, but you get what I'm saying. Starship with a sun shield would look pretty cool. Somebody was telling me, Space Engineer, about an idea for a depot ship, right? A depot ship that just stays up there. And we were talking about that conversation morphed into, can a super heavy booster SSTO? If you just had super heavy with like a Starship nose cone, no flaps on it, just go all the way up into space, right? Would it, you know, could it SSTO? And with 13 engines, yes, probably. I would say yes. Yeah, you could probably do it with 13 Raptor 3s. If I'm thinking about this right. Yeah, you probably could. And then you have a gigantic propellant depot up there. No use, though, very little payload. Well, that's your depot, dude. Yeah, you're not going to move dick up there, right? You're not going to move nothing. But you send that up there, keep it there. 13, you have 13 Raptors, right? And then starships dock to it and refuel it. And it just becomes your refueling ring. Haven't they shown off Starship Depot concepts? Yeah, Steve, that's the other, and you know, that's the other thing that I'm thinking about, guys. I think there's a reason why Starship V4 and the potential depot starships are literally the size of a freaking super heavy booster. Have you seen the long Starship renders from SpaceX? It's a super heavy with flappies on it. Where's the picture of it? I'm looking for the diagram. Give me 1 second. He has more theories, Derek? Shun Wang saying, what's my boy saying here? Starship could generate 100+ kilos of water per day solely from the boiled off methane and oxygen. You reckon they'll need to build a new Mechzilla for... What is that? That video just decided to play? That scared the crap out of me. Why did that video just decide to play? I mean, I'm not upset. I'll play it, but... Wasn't even on that tab. I mean, I'm not upset, but that's just strange. Why would it do that? I was over here. Why would it play the damn video? Dude. All right. Surprise super heavy. Why would it do that? Dude, that was a low-key pucker. I'm like, what's going on? All right. Starship could generate 100 kilos of water per day slowly from the boiled off methane and oxygen. Rotating a 9-meter diameter section at 9 RPM would create 0.3 AG, Mars-like artificial gravity. Yeah. Musk scare. Yeah, right. Imagine swimming in a vertically circular standard 25-meter pool where the place you just swam through is now directly above your head. That pool is not just for leisure or exercise. It offers critical protection against solar storms at Venus distance. I don't feel excited during a mission. I feel excited when planning one. First class. Nice. I don't think swimming around in your solar shield is the, you know, smartest thing to do, but, you know. Dock 2 starships nose to nose and make them rotate. Yeah, I don't think they're far enough away from each other, dude. A 9-meter diameter centrifuge would not be comfortable to stand in. That's what I mean. You got to be a certain distance away for your brain to not make you want to puke. Let me say that. British Airways didn't have money to fly first class every day for the next 300 years. Dude, that must be nice, right? Like, I'm gonna fly. I'm gonna fly here. I'm gonna fly first class. Whatever. I'm gonna plan this mission to space on my first class trip. Have you seen this from Eric Berger? Is this the Yoda thing? What do we got here? So Eric Berger tweeted the Yoda upset thing. This cryptic tweet referred to a lot of crappy things I heard yesterday in the space industry. One of them is this. There is a concerted lobbying effort in DC saying industry can build a LM-like lunar lander in 2 years, and it should be a second option for Artemis 3. Deuterium would be a great solar shield. Yeah. To expand a bit further, the lobbyist argument is that fixed price contracts got us into this mess, and a cost-plus lander built by a traditional contractor is the solution. The problem is that there are some people in the agency taking them seriously. Here's a link on centrifuges. All right, let's go. I don't... Oh, man. I'm not trying to piss in Eric Berger's cornflakes. I don't think that that's the stupidest idea. I'm sorry. I'm sorry. I don't think that that's the dumbest idea. That's actually not... That's hedging your bets pretty well, and that's being pretty damn smart about it. The camera focus seems a little bit off. We good now? We good? Is it good? Can I get a cost-plus contract to reinvent the wheel? The problem is not cost-plus, it's traditional contractors. Creation, what Spoiled said. I wouldn't be against something like that. But here's the thing, fellas. All right, hold on one second. But the first one out to Mars will be filled with Optimus robots, batteries, solar panels, and construction materials. I want to live in that timeline, Tessa. Here's the thing, fellas. I've talked about this before. I wouldn't mind if NASA wanted a conventional option for, like, with a hypergolic lander. That's something we can get done quick. We could make another lunar module. That's not a big deal. Here's where I'm going to start asking questions. I don't even care that it would be a cost-plus thing. Cost-plus makes sense if you need to get it done quick. Cost-plus only works with deadlines, okay? Fixed-price development, I agree. I don't agree with Eric Berger. I think that's stupid. Fixed-price development is how things end up like Starliner. I mean, granted that I think they got more to figure out than just their fixed-price contracting. I think Boeing has more to figure out than that. But that's the idea. I don't necessarily mind cost-plus when it makes sense. In order, a cost-plus contract a cost-plus contract means with a firm deadline, and the firm deadline here is getting to the moon before the Chinese, 2028, right? A cost-plus contract with a firm deadline like that means that you're letting your mission drive your funding, which is not a bad thing. It's really not. I don't care what anybody says. That's not a bad thing. You know, you're going to sit here and make the argument that cost plus is a bad idea. Cost plus is a bad idea. Cost plus is a bad... The whole Apollo program was basically cost plus. Okay? If you have a deadline and you have solid goals, cost plus is fine. There's nothing wrong with that. If anything, that's good because that means, because you don't know how much it's going to cost. That's not a bad thing. It really isn't. I don't think it's bad to have options. I think he might be right in the fact that it's kind of interesting that NASA isn't putting their faith in SpaceX. They don't think that SpaceX is going to be ready. That's if Eric Berger's sources are pretty good. No matter, I mean, I don't agree with his conclusions. His conclusions were all wrong. Halsey acted stupidly. No, I think his sources are right, and I think they're good. I used to bug on him all the time because, I was like, oh, sources is not journal. But his sources clearly are right. But they're clearly good, right? But a cost plus lander on a short deadline like that, 2 to 3 years, totally doable. That's doable. But here's where I agree with him. Okay. 1, that doesn't show confidence in SpaceX. 2, that's kind of telling. 3, okay, you're going to build another lunar lander. Sure. Go ahead. Yeah, build an exact copy of the LM for all I care. That's fine. How are you getting that to the moon? Exactly. How's that going to work? How is that getting to the moon? SLS? That can't put that to the moon. So SLS has about 40 metric tons translunar injection capacity. Orion is 25. A lunar module, the lunar module is 16 tons. Ascent and descent stage, 16 tons. SLS can do 45 metric tons TLI. Or no, not 45. It could do 40. So with the EUS, with the Block 1 EUS. So what does that get you? That seems right. Like, oh, the EUS should be able to shoot a lunar module and Orion on a translunar injection, right? Should be right. It should be able to do that. Orion's service module can't get it into low lunar. Even if Orion could somehow get an LM into a rectilinear halo orbit, it means nothing. It means nothing. You don't have enough delta V to land a lunar module from rectilinear halo. That's not a thing. Because Orion's service module is dookie. That's where I'm kind of like, okay. So other architectural options need to be on the table here. You need to be able to build a gigantic hypergolic lander. Something that can get from rectilinear halo back down. And you need to be able to send that to the moon. So that means you're building something on par with like the Altair lander from Constellation, which was using hydrogen, if I'm remembering correctly, and you're making it hypergolic, not insurmountable. Okay, what propulsion are you using at this point in time? You're not using AJ-10s to do that unless you clustered them up. Not happening. How are you going to do that? What engine are you going to use? What hypergolic engine is there? You're going to remake the LMDE? Propulsion research takes time. EJ's right. Orion can't get it up. It's that service module soapbox. It sucks. I understand where you're coming from completely, but I feel like Eric is just jaded with the current state of aerospace, and honestly, I don't blame him in the slightest. I don't think he's jaded. I don't think that... Look, man, Steve, we're not set up. We are not set up for a space race. The whole entirety of Artemis is set up for sustainable lunar exploration. It specifically is the opposite of the Apollo program, which was expedient. And now we're just going to switch gears? Now, don't get me wrong, dude. I don't care. We switch gears, that's fine. As long as we don't tank the Artemis contracts that are there for sustainable lunar exploration. If NASA wants an option that's going to get them there more expediently, I don't necessarily have a problem with that. I really don't. I don't have a problem with that. It's just going to be really funny when their little poopy doopy baby hypergolic lander is sitting on the moon and a Starship HLS lands next to it. But whatever. How much delta V does the USD orbit vehicle service module supposed to have? 50 meters a second delta V attached to the International Space Station, Andrew, from what I understand. So, fellas, I don't necessarily think them doing that is a bad idea, and I don't think them doing it with a cost plus lander is a bad idea. I think NASA should have their own in-house lander. That would definitely get us back to the moon expediently, and even put us in a position where we could potentially beat the Chinese. Wouldn't have a problem with, I seriously don't have a problem with any of that. One, I think if you're going to do this, you shouldn't terminate HLS or SLD. That would be stupid. You should keep going with that, and NASA should have their own in-house architecture to be able to get to the surface of the moon. I don't have a problem with that. What I do have a problem with is that this lander is abstracted. It's not just building another lunar module. You're not just building a copy of the LEM. The Orion can't do it. You can't do it. You'd have to redesign the service module if you wanted an Apollo-style architecture at this point. Are we gonna go and do that? We just got that stupid thing working. Now, I will say, if you're going to do this, you would have to upgrade Orion's SM. Upgrading Orion's SM is going to change a bunch of things. You're going to, the Orion service adapter is going to need to be redesigned for a bigger service module. It's possible. You could do it. Stretch Orion's service module if you really wanted to. Who's making it? The Europeans? How's that going to work? You have to redesign the aero fairings on the capsule. Got to redesign those. Took them 10 years to get those right. You have to redesign that. I don't have a problem with that. You could just redesign it for a bulkier surface module, eliminate the aero surface modules completely. Then you'd need to cover your solar panels somehow on the way up. A blister fairing on the side like Rocket Lab could be doable. But do you see how many things you need to redesign at this point? You're redesigning a lot of things. New plan. Let's contract China to do it. They tried to do that in the 90s. Look up Intelsat 708. It didn't work. You could take the booster second and third stage with Orion and a lander. Could you take the booster and a second and third stage with Orion and a lander on top of it? I don't know. Can you add extra boosters to a Falcon Heavy? No. Old plan. Let's contact China to do it. Good idea. No. That's more Leo mass dedicated to Orion then. Bingo. Gah. Yeah. The only way you're going to do this is you're going to have to build a jumbo LEM. You have to take the LEM and double the size. That's the only way that's getting done. You got to double the size of the damn LEM. In which case, you're doubling the size of the LEM, meaning you're probably not going to be able to move that and Orion into space in one shot. So, how is this going to work? So direct then, forget Orion. So, God, okay, if it was up to me at this point, I would just get rid of the EUS. Get rid of it. It's a pile of dog shit. Oh, excuse me. Sorry. I didn't mean to swear. My bad. I'm really trying hard not to do that. Not because family friendly, I'm just trying to eliminate swearing out of my vocabulary. Not for any particular reason, just to see if I can actually do it, if you really want to know. Get rid of the EUS. Build a lunar lander that has enough delta V to be able to do your insertion directly. Or put it on top of an EUS, get that all together in low Earth orbit, and shoot Orion up on there with an upgraded service module on a new Glenn. Or a Falcon Heavy, or something. Earth orbit rendezvous. And then the EUS could get you and your payload like most of the way there. You'd have to dispose of the EUS after translunar injection, and then you use the lander, the uprated lander, to circularize you in low lunar with Orion. Lander goes down, ascent module comes back up, Orion separates, does the Apollo thing. That would do it. That would give you enough delta V. To use the lander for LLO circularization, it's possible. But now you need to have the EUS be able to shoot out like 60 tons TLI
to do something like that. I.e., you'd have to separate the EUS mid-translunar injection burn and then fire the lander's engine to do the rest of your TLI insertion, and then also have the delta V to circularize in low lunar. This is why I hate the EUS. It's an anemic piece of junk if you're going to do any type of expedient architecture to the surface of the moon. Couldn't they throw up the lander on another launcher? Well, I'm saying launch SLS with a cargo fairing in the EUS on top of it, and launch Orion on New Glenn or something, and dock that in Leo, and then have the EUS do some of your insertion, and then have the lander do the rest of the insertion, and have the lander circularize you in low lunar, and then have the lander go down and land. Ascent module comes back up, docks with Orion, Orion goes home. The EUS needs to be man-rated too. It's already man-rated. The man rating is being built into the design. Yeah, I got you. You planning on spending time around kids? No. I am doing it just to see if I can. This generally feels like we're back to square one for the 5th time. I'm 90% sure that is a page directly out of the Constellation textbook. Yeah, Steve, and I've been saying for the past 15 years that Constellation is a very good architecture. And I think it's a good idea. And we shouldn't have not done it. I mean, Steve, there's a reason why I keep saying canceling Constellation had the worst, we're dealing with the repercussions of that. And we're going to be dealing with the repercussions for that until somebody steps up and tries to shift it back. And it's funny because Eric Berger's saying that he's saying that like it's doomsday, but it's not. I've never seen anybody get upset about having more options to land on the moon than less. That's very strange. It's a very strange thing to me to be upset about. That's a very strange thing to me to be upset about. I mean, I understand where he's coming from. I really do. I get it. If, for instance, like they cancel HLS and they cancel SLD and then award this huge cost plus contract for a lunar lander, I'd be pissed. That would be stupid. Yeah, Van, exactly. I highly doubt they'll approve a new lander without cutting funds anywhere else. How about SLS EUS lander, separately SLS EUS Orion moon rendezvous? Yeah, sure, you could do that way. Yeah, Bob, you could do that if you really wanted to, yeah. You'd have to budget 40 tons for the lander, but you'd need 2 SLSs at that point. It might be an issue of more people to take the same size pie. They need a funding increase to make any sense. That's the other thing, and that's what I mean about fixing this problem. We can't beat around the bush. Commercializing the entirety of NASA's space program isn't saving anybody money, it's just defunding NASA. That's what they mean when they say we're saving money by using commercial. That means less money for NASA. You can cut it any way you want. It's less money for NASA. Blame Norman Augustine. I have taught you well, Nova. Yes. Yeah, Geeson. Once again, I don't think this is necessarily a bad idea. As long as you don't cancel HLS and SLD, I think this is a really good idea, actually. If NASA wants to field an in-house hypergolic lander to expediently get back to the moon for Artemis 3 and then use HLS for like Artemis 4 and 5, sure, go ahead. I don't have a problem with that. That's fine. And then use SLD for Artemis 6, 7, and 8. That's fine with me, dude. Yeah, I don't have a problem with that. You should do that. Please do that. But once again, it's not about taking, it can't be at this point about taking money from something. You're going to have to, I know, Congress is going to have to increase NASA's funding. Oh no. I don't trust the Rule 8 people to not do that, though. Yeah, Gießen, I mean, the incumbent administration has an axe to grind with American exceptionalism, don't you think? It would happen this way. Think about it, dude. It would happen like this. Of course it would happen like this. Why wouldn't it? Prove me wrong. It would happen that way. Anyway, it's 9 o'clock, guys. That was a long space news. That was a long space news. Yeah, Alex, I don't think that would work. I don't know what's harder, coming up with lunar architecture we can keep or getting a girl's number. Have you tried asking? Have a good night. I was going to play Summer Car for after hours. You guys want to stop? We can stop now. That's fine. We can stop now. That's fine. I was going to test out the new racing rig. I fixed the racing rig chair. Suggestion for training yourself on not swearing. Have a treat that you only get to have on days that you don't swear before you go to bed. Yeah, I fixed the racing rig on stream early this morning, Steve. I've been streaming since 11 a.m. What's the uptime? 10 hours? I got 2 more hours of Summer Car in me. And a positive reinforcement. Bring back the swear jar. No, I think I'll just stop swearing. That's fine. Isn't Blue Origin's lander for a December launch? Yes, Rick, but that's the Mark 1 lander. Mark 2 is the one they want crewed. I mean, if we're going to explore options with lunar landers, I would probably have pay Blue to human rate Mark 1, but that's just me. If you don't swear, then maybe the Sox will get to the World Series next year. I don't need to do that because that's going to happen anyway. No swearing, so BF6 is out. I said it was a challenge, Mutter. I didn't say it would be easy, man. I keep asking people, EJ, but so far no one's given me a sustainable lunar architecture. Yeah. And I think people, Aqualex, you really want my honest opinion? I think people are off their freaking rocking chair if they think Gateway is sustainable architecture. You're out of your mind if you think that's a good, like, oh yeah, that's the way to go. Anyway, good conversations, dude. Space Engineer, if you're still out there, thank you for showing me the diagrams. I do appreciate it. Guys, go give Space Engineer a follow on X. Really, really top shelf info about Starship and engines and whatnot. He's a good dude. Good dude. Give the guy a follow. Why no Gateway? Lemon, my problem with Gateway is that the best time to launch Gateway was like 5 years ago. If Gateway was up there right now, I wouldn't really have a problem with it. I think it would be really cool. But that program is seriously mismanaged at this point, to the point where you just should... No. Gateway is great if it's 2015. Bingo. Gateway is amazing if it's 2015 and we don't have to worry about near-peer adversaries trying to claim the moon. I.e. not being in a space race. Gateway is great if we live in the 20-teens fantasy land of NASA doing crazy stuff like redirecting asteroids with less money somehow. Transitioning to a space race made Gateway a distraction. Bingo. That's why the best time to launch it would have been 5 years ago. But we couldn't do that because they were too busy forgetting to take into account the wire harness mass in their total mass evaluations. So, you know, whoever's running that program is kind of a moron. Yep. Now, don't get me wrong, people make mistakes. I get it. That's fair. I make mistakes all the time. I don't forget the mass of the wire harness when figuring in total mass of my space station modules. Anyway, fellas, that was a good space news. I enjoyed that. I hope you guys had fun. I think it's time for my summer car. Get SpaceX to put HLS in orbit. There's your gateway. Yeah. Thanks for the rocket review. As always, you're a gentleman and a scholar. My pleasure, Domingo. Pleasure's all on this side of the screen, dude. I hope you guys enjoyed that space and rocket review. I have a hard stop at 11 p.m. tonight. It's 9 right now. So we got some summer car to play. I got to get going. So I'm going to jog the VOD. I will see you guys in a second. Just going to take 5 here, switch up the YouTube VOD and go. Thank you for watching Space News. Stay tuned for Summer Car, attempt number 4. The attempt 4 playthrough for 2025, where we've somehow completed the rally race and are teeing up for the next one. I'll be back momentarily.